is second law of motion. Define Newton's second law of motion. What did we say in that case? When a net or resultant force, acts on an object, then an object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of the object. I repeat, if they say state Newton's second law of motion, we say that an object, a net or resultant force acts on an object, the object will accelerate in the direction of the force, and that the acceleration is directly proportional to the force and inversely proportional to the mass of the object. And then this formula here, or this law, is what we write as our F net equals to MA. F net equals to MA. Whatever we have said here is in this same equation. We are saying that the acceleration is proportional to the net force, and also acceleration is inversely proportional to the mass of that object when a non-zero resultant force acts on it. Then they can state Newton's third law of motion. Newton's third law of motion, how do we state it? When object A exerts a force on object B, then object B simultaneously exerts an opposite directed force of equal magnitude on object A. And then I can also say that state Newton's law of universal gravitation. This is how we state it. We say that each body in the universe attracts every other body with a force that is directly proportional to the product of the forces and inversely proportional to the square of this between their centers, and inversely proportional to the square of the distance between their centers. And then another one here, though they will not ask you how to define it, is the weight. Weight is the gravitational force the Earth exerts on any object on or near its surface. Now, guys, you must know these definitions to get better grades. Are we together? All right, after getting our definitions now, we're starting with this year's question paper, November 2025, question 2. It says a block of mass 5 kg is at rest on a rough horizontal surface. So here they're giving us the mass, okay? Assigned the of the mass 5 kg rest on a rough horizontal surface. The mass is 5 kg and it is at rest on what? A rough horizontal surface. When a constant force F of magnitude 18 newtons, okay, of magnitude 18 newtons, they say acts on the block at an angle theta to the horizontal, the block experiences a maximum static frictional force. The block experiences what? A maximum static frictional force. And then they say, see the diagram below. Okay? So in our diagram here, as you can see, we have this force of 18 newtons, okay? And it is acting at an angle theta, pulling this 5 kg block, which is on a rough horizontal surface, as they said so. Now 2.1 they say, state Newton's second law of motion in waves. We have said that when a net force acts on the body will accelerate in the direction of the net force, with the acceleration directly proportional to the net force and inversely proportional to the mass of the body. That one is done. Next question, they say now, draw a labeled free body diagram showing all the forces acting on the block. So we need a labeled free body diagram. Now because it must be a free body, we're going to use a big dot to show our box or our block, because it must be a free body. So note that in a free body diagram, all the forces, all the arrows must be pointing away from the dot. So now this block has got weight, okay, has got weight. Then the surface exerts what? A normal force, okay, exerts a normal force. And then because there is, it's going to be opposing motion, like we said, that is F static, and then applied force here. But because we want a free body, you're going to have it like this now, okay. So you're going to have the normal force and the weight opposite each other, okay, like this. And then as you can see, we have got an applied force at an angle, so we're going to put it there as well. Then from there we have the frictional force. So we're talking about free body. So we put a big dot. We put a big dot on our arrows here. So this big dot here, it represents the body. It is a free body, okay. So then we have the applied force acting at an angle, okay, this one here, like this. It's at an angle, and then the surface is a rough surface. So we have also the arrow showing the force of friction, which you call what? Static frictional force, okay. Now this force must be opposing the motion, and because it's on a horizontal surface, the motion, the arrow for the friction must be pointing like this. Hope it makes sense to you. Arrow on top is the normal force. They said labeled, so this is F normal. And then here, now if you know the applied force, like in this case is 18, put it there. So this is 18 newtons. Or you can say force applied. This is the weight which I'm going to call Fg, or you can use W, okay. Then here I have the static frictional force, the maximum static frictional force. Yeah, next question says what? They say that now the horizontal component of the force is 15 newtons. Calculate theta. Now this force which you see here, the 18 newtons, has got points, okay. One component is horizontal and the other is what? The other is vertical, okay. So now the horizontal component, they said it is 15, okay. So I'm going to put it here like this. And then the other component, it is a vertical. Just give it a red color here, vertical. And in this case, it comes like this, okay. Now all the components, horizontal and the vertical, they must be perpendicular to each other, okay. And then they must be pointing where the original force is. This 18 is ending, starting from here to here. So this is our horizontal component, which you call Fx, and then this is our vertical component, which you call Fy. Now this is our theta here, angle theta. Now the question gave us our Fx at 15 what? 15 newtons, okay? Looking for theta. So from here, what do we see? Now our Fx is adjacent, and so for that matter, we're going to use, if you talk about SOHCAHTOA, I'm going to use cos, okay? So I can see that the cos of theta, okay, the cos of theta adjacent, in this case, which is our horizontal component, Fx, okay, divided by hypotenuse, which is the applied force F, or you can say 18. So from here, because we're looking for the theta, so that our cos of theta, now the applied for the horizontal component, they gave us 15, okay, 15 here. Now the force is 18, so to get our theta, we find the cos inverse of 15 divided by 18, and then what do you get? Calculators, what do you get here? Here on my calculator, it gives me 33.56. It gives me 33.56. 33.56 degrees. That's my theta. That is question 2.3.1. Now here they want the coefficient of static friction. That is question 2.32. They want our coefficient of what? This one here, of static friction. Okay. Now what do we know? We get it is given by the coefficient of static frictional force multiplied by the normal force. Multiplied by what? By the normal force. So in other words, if I can get my normal force here, I will get my coefficient is on here. But now because the body is stationary, you guys can see that this Fx equals to F static because it is stationary. Okay, so I'm saying because it is stationary, my horizontal component equal the maximum static frictional force. So in this particular case, I'm gonna say actually to the component, okay, which is what? Which is 15. So in other words, I can see that my static frictional, the coefficient equals to that horizontal component divided by what? By normal force. Divided by the normal force, okay? That's F normal. So this one I know it is 15. They gave it to us already. So my task here is to find what? The normal force, F normal. Now this normal force, if you look at our diagram here, the normal force together with the vertical component, they're all pointing up. They're equal to the Fg. Okay, so we calculate in this case our F normal, okay, our F normal with the vertical component, that is Fy, equals to Fg, equals to the force of gravity or the weight. Now from here, because I'm looking for the F normal, when I say F normal equals to Fg minus what? Minus the vertical component. But how do you find the Fg? I use mass times gravity. Okay, so I'm gonna say here equals to mg, okay, equals to mg, then minus what? Now the vertical component is given by the force applied times sine of theta, but because we have our theta already and the mass is 5 kg, let's say 5 here, times 9,8 times 9,8, then minus our 18 sine what? Sine theta. But theta we got what? 33,56. 33,56. Okay, so here, calculators, what do you get? Final answer. What do we get here now? Calculators, what do we get here? Okay, so here, on my calculator, it gives me 39,05. So my F normal is 39,05. It is 39,05. But don't forget, I'm looking for the coefficient of static frictional force. So if I can say this is equation 1 here, so from equation 1, my coefficient of static frictional force equals to 15, okay, divided by what? By 39,05. So when you get calculators here, it gives me 0,38. 0,38. 0,38. Now this coefficient doesn't have units because it's a ratio. It's a ratio between the normal force and the frictional force. Okay, let us proceed. Next question here. There is that the angle increased while the magnitude of the force F remains constant. How will the friction acting on the block be affected? Choose from increases, decreases, or remains the same. Explain your answer. I repeat, the angle theta is decreased while the magnitude of the force F remains constant. Then they say, how will the friction acting on the block be affected? Choose from increases, decreases, or remains the same. Explain your answer. So here, before we get our answer, let us begin with the explanation. Okay, begin with what? The explanation. Make most to us. Okay. Now we know that the frictional force, that is the static frictional force, equals to what? Is directly proportional to the normal force. Okay. Are we together? But then our normal force, from the given expression there, like we saw, is given by the weight Fg, minus what? Fg minus the vertical component, which is Fy. Now, when our theta decreases, okay, when our theta decreases, what happens? Okay, let's find out here. Now, our Fg is still mg, okay, and then our theta decreases. Remember, we were using the same force, which is 18 what? The force was 18, so it's going to be 18 sine what? Sine theta. 18 sine theta. Okay. Now, when theta decreases, this normal force will increase. Okay. So because normal force increases, and then the normal force is directly proportional to the frictional force, so also frictional force will also increase. So the answer is what? We say it increases. Why? Because the frictional force is proportional to normal force, and yet normal force increases when theta decreases. When theta decreases. So because our theta decreases, from this expression here, from this equation here, this one, our normal force will do what? Will increase. Are we together? All right. Thank you so much for watching. Catch you in our next video. Bye bye. All right. Now we are doing question 2, May June 2025, and it says a crate of mass 25 kg slides down a rough inclined plane at a constant speed of 2 meters per second towards point A, while a force F acts on it parallel to the incline as shown below. A constant kinetic frictional force of 40 newtons acts on the crate when the plane is inclined at an angle of 30 degrees with the horizontal. I repeat, they say here that a crate of mass 25 kilograms, okay, slides down a rough inclined plane, okay, slides down a rough inclined plane at a constant speed of 2 meters per second, okay, and then they say towards point A, while a force F acts on it parallel to the incline as shown in the diagram below, okay, and then they say a constant kinetic frictional force of 40 newtons acts on the crate when the plane is inclined at an angle of 30 degrees with the horizontal. Okay, so here now they say, you can see this crate here. Now guys, please don't set your own question. You see that the applied force is upwards, like it is upwards, are together, but the question says that the crate is going downwards. Together is going downwards. I know some students, because they see applied force acting upwards, they are gonna say that the crate is going upwards in their calculation, and then they will get it wrong. So please don't set your own question. Okay, they say here 2.1 state Newton's first law of motion in words. Now we just said a few minutes ago that a body will continue to remain in its state of rest or continue moving with a constant velocity unless a non-balanced force acts on it. Question 2.2, they said draw a labeled free body diagram. Draw a labeled free body diagram showing all the forces acting on the crate as it moves towards point A. Now, if they say all the forces, it means you show all the forces acting vertical, acting perpendicular, and horizontal to the plane. Okay, so in this particular case, because they're giving us 4 marks here, we are going to have 4 arrows coming from the dot. Okay, so here we go. Now, guys, note that here our block is on the incline, unlike in the previous question we just did now, whereby it was a horizontal surface. This is at an incline, and so because of that, it means that we're gonna have our incline like this. To make our things simple, let's have our incline like this. Okay, now this incline is what I'm putting here right now. Okay, if it is the incline here, are we together? By the way, let me first show you on what we have here. Now this block here, we are gonna, it has got weight. It has got the weight. This weight is acting vertically downwards. Okay, that's our FG altogether. And then there's this applied force, which you see that force F. Okay, and then being on the surface exerts a normal force. Exerts what? A normal force altogether. And then don't forget that the surface is a rough surface, so because it's going downwards, like I told you here, we are gonna have the frictional force opposing the motion. We're gonna have what? Frictional force opposing the motion. That's our FK. Okay, so now all these forces, you see there are 4 of them coming from the dot. They form our free body diagram. So here we go. We're going to first put our free body. Okay, so this is the free body here. This is our free body here. Are we together? You put a big dot. Now I can start with a weight, that is FG. Let's do the weight, that is FG. Now this FG, it is pointing downwards. Okay, as you can see in our diagram, it is pointing downwards. That's our force FG. Then we have the normal force, which must be perpendicular to the surface. Which must be perpendicular to the surface, like you see it here. Hope it makes sense to you. That's our normal force, which is what? Perpendicular to the surface. And then we have the applied force F. We have the applied force F. You see it is pulling upwards next, so I must put it to act upwards. So the applied force F, it is parallel to the line, like you can see. It is what? Parallel to the plane, and that's what we have there. But before, also apart from applied force, also what we call as what? The frictional force acting on the what? Acting on the plane, on the object. And now this frictional force is also opposing the motion. Okay, the frictional force opposes the motion, and this frictional force, because the block is going down the slope, then the frictional force must be upslope, like you see it here. Okay, so this is frictional force here. Yes, now after putting the arrows, now you can remove the incline if you want to. You can remove the incline, but if I remove it here, I see it's gonna delete everything here, right? It's gonna delete everything here. Okay, no, okay, it's fine. So now what I have now is the free body diagram. Okay, this is the free body diagram, but they said it must be labeled. Okay, so let's label it now. So here we have our normal force, which is F normal. Okay, and then we have the applied force F, and then we have the kinetic frictional force. Okay, then we have the weight, or call it FG. All right, guys, this is our free body diagram. That is question 2.2. Then next here they say that to go ahead and do what? They say that calculate the magnitude of the force F. Now looking for this force F here. Now the block is going down, but it's going at a constant speed. At a constant speed. Okay, so because of that, it's not accelerating, acceleration is changing velocity. So because of that, if you're gonna say 22nd law, our F net, okay, equals to MA, but then we must equate it to 0 because it's not accelerating. Now, why is the block going downwards and yet the applied force is up the incline? It means that it's going downwards because of FG parallel. Let me show you here. Now, this arrow which you see in red is called the FG, but on the incline, it has got two components. One component, it acts parallel to the what? Parallel to the incline. Then the other, it acts what? Acts perpendicular to the what? To the incline. Okay. So this arrow here, which you see here, okay. This arrow which you see here is the one which you have to see. Let me do it again here. So this force which you see in red, we call it FG. Now this FG has got two components. One component, this one here, is called FG perpendicular. This one here is called FG perpendicular. Why do we call it like that? Because it is perpendicular to the surface. And then this other component, this one here, this other component here, this one is called FG parallel. Why is it said so? Because it is parallel to the what? To the incline. So this one here which you see now is the one which is taking the block down the slope. I repeat, this one here, this FG perpendicular, this FG parallel is the one which is taking the block down the slope. Don't forget that any force has got two components, and those components must be perpendicular. This is FG perpendicular, which we use for when we're dealing with the frictional forces, coefficient of frictional forces. And then this FG parallel, if we talk about motion down the slope. Okay, so now our F net here, you guys can it means we are gonna say our FG parallel, okay, FG parallel, and then minus the applied force which you're looking for, and then minus Fk, that is kinetic frictional force, equal to 0. Now, how do you find the FG parallel? It's given by mg sine theta. Mg sine theta. Mg sine theta. We're looking for this force F. Now, they gave us frictional force as 40 here. You can see it is 40. So, minus 40 equals to 0. Okay, so I'm looking for the force F. Now, the mass given here is 25. I'm going to say here 25 times 9,8, okay? And then they give us the angle as what? As 30, so times sine of 30 degrees. And then minus 40 will give us force F, which we are looking for, okay? Now this one here, from the calculator, what do you get there? Yeah, it gives me 122,5. So this is 122,5, 122,5 newtons minus 40 equals the force F. So in other words, my force F equals to 82,5 newtons equals 82,5 newtons. All right, hope guys we are together. Let us proceed. Next question here. They say that now when the crate reaches point A, here from point A, the force F is removed and the angle of inclination decreased immediately to theta. There's the theta here, so that the crate continues to move at 2 meters per second. Okay, it continues to move at what? At 2 meters per second towards point B. Now note that it continues to move at the same speed of 2 meters per second. Again, it is not accelerating, so meaning also here acceleration is 0 because it's still moving at the same speed. Okay, and so now what must we do? They say that now use the relationship between the forces acting on the crate between points A and B to show that the coefficient of kinetic friction equals to sine theta over cos theta. So this is 2.4. Because the crate continues to move downwards, it means that again, if we say that our F net equals to A, which we said equals to 0 because of the constant speed, okay, why is it going down the slope now? Now, because we have removed the force F, but still there is the incline, and because of the incline, we still have our FG parallel, which is taking the block down, the crate down the slope. So now FG parallel minus frictional force, okay, should be equal to what? Should be equal to 0. Okay, so now our FG part is given by mg sine theta, mg sine theta, and then what about frictional force? It's given by the coefficient, okay, times FG perpendicular, times what? FG perpendicular. Now, if you say mg sine theta here, that is for the FG parallel, then our FG perpendicular, we use what? We use mg cos. So use mg cos of theta, mg cos of theta. As you can see, my coefficient, which I'm looking for, will be given by what? By this mg sine theta, okay, divided by what? Divided by mg cos theta, divided by mg cos theta, and the mg's can cancel out, and so therefore my coefficient of kinetic frictional force equals to sine theta divided by cos theta as required. So that's our answer. I hope, guys, we are still together. Next question, they say here that 2.5, they say the coefficient of kinetic friction between the crate and the inclined plane is 0.19. Okay, using the identity tan theta equals sine theta over cos theta, calculate the frictional force as the crate slides from point A to point B. So I'm looking for the frictional force, that is my Fk, as it slides from point A to point B. Note that initially our crate, our incline was 30 degrees, but when the crate reached point A, the force was removed, and then the inclination was decreased from 30 to angle theta. That's what they said here. Now, when they decreased it, again, the crate continued to move at the same speed, which is 2,5, which is 2, 1, because the force F was removed, which was opposing motion. Okay, so now we're looking for the frictional force acting on this what? On this crate. Okay, so now because we have our coefficient, and we have, so now we know that tan theta, this is 2.5 now. Note our tan theta from up here, our tan theta, the same as coefficient, which is what? 0.19, and so we can get our theta here. Our theta equals tan inverse of 0.19, and so that's what you get here. Tan theta, tan inverse of 0.19 here it gives me 10,76. Here I'm getting 10,76 degrees. Okay, now they say they want frictional force, né? But what do we know? The frictional force Fk, okay, equals the coefficient, okay, times normal force. And we know that the coefficient is given to us, né? It is 0,19, okay, 0,19. What about normal force? It is mg cos theta. It is what? It is mg cos of theta, okay? Now that we know our theta, we're going to say 0,19, 0,19. The mass is 25, right? The mass is 20 what? They said it is 25. Let me confirm here. The mass is what? 25, no? Here, 25 here. All right. So I put 25 here. So times 25 here. And then times 9,8. Times 9,8. And then the cos of theta. But now our theta, we know it is 10, what? 10,76. So it's going to be our answer here. Calculators, what do you get? Now here, my calculator, it gives me 45,73. So this is 45,73. 45,73 newtons. Guys, note in our previous question, that is for 2025 November, they said what happens to the friction when the angle is decreased. In the same way here, when our angle decreases, there's increase in the frictional force. So this answer is what we have here, and I hope it is correct. Okay, so for any questions, please don't hesitate to call us on 0785 222 041, or you can click on the link below to join our extra classes. This is Patrick Kamala, tutor, educator for mathematics and physical sciences online. We do both DBE and the IEB. Thank you so much for watching. Catch you in our next video. Bye-bye. Question 2, November 2024. Now, please, the best way to benefit through these videos, please, students, listen carefully. You can pause the video and try out this question first, okay? Try it out first. When you are done with your answers, then you can replay the video and start marking your work. In that way, you'll be doing practice with understanding. Okay, now this question says that in an experiment, a crate of mass 8.5 kg lying stationary on a rough horizontal table is connected to a mass hanger by means of a light inextensible string passing over a frictionless pulley, as shown in the diagram below. The mass pieces are added to the mass hanger and the acceleration of the crate is measured. The experiment is repeated several times by adding different masses to increase the hanging mass each time. Ignore the effects of air friction. One more time. In an experiment, a crate of mass 8.5 kg lying stationary on a rough horizontal table is connected to a mass hanger by means of a light inextensible. Inextensible means that the tension is constant, okay? Inextensible string passing over a frictionless pulley as shown in the diagram below. The mass pieces are added to the mass hanger and the acceleration of the crate is measured. The experiment is repeated several times by adding different masses to increase the hanging mass each time. Now they say here, this is the crate This is the mass hanger with mass pieces. These are 3 so far. They say the results obtained were used to draw the sketch graph below. Now here we're having acceleration on the y-axis and then the hanging mass in kilograms on the x-axis. 2.1, define the term static friction. Define the term static friction. We said that static friction is the force which opposes the tendency of motion of a stationary object and is acting parallel to the surface. Now they say here also that draw a labeled body diagram showing all the horizontal forces acting on the crate just before it starts to move. Now note here they're saying horizontal, so don't be in a hurry. Please answer the question. Horizontal forces, not vertical. This is the crate here. So here the mass of the crate, that is MC, it is 8.5, okay, kilograms. And then you see the tension will be pulling this way, then opposed by friction on the table, acting this way. So now that's what we want here. They said just before, so it's going to be static, F static frictional force. So here, in that case, we don't need the normal force and we don't need the weight. Okay, so we simply have our what? We simply have our diagram like this now. Okay, so in this case, our diagram will be like this. So we have this one pulling this way, opposed by friction, okay, and that is question 2.2. So the free body, you must put a dot here to show the free body. You put a dot to show the free body, okay. They said just before it starts to move, so they're equal. So this side we have the tension force, this side we have what? The static frictional force just before it starts to move. That will be our maximum static frictional force. Okay. Now I don't put the normal and the weight because I am answering the question. They said horizontal, not because I don't know the normal and the weight, but because I'm answering the question. They said they want all the horizontal forces. Okay, next question. That was 2.2. Now here, 2.3.1. What do they want now? Let's find out. They say that calculate the coefficient of static frictional force. That is our mu s. Okay, this one here, what we're looking for now. Now understand. Now here, before the body moves, before the crate moves from our hanging mass, that is zero acceleration. That is zero acceleration. Okay. So in that case, the mass for the hanger is going to be the 4.2. So the mass on the hanger is going to be what? 4.2, because the 4.2 here from algebraic it has zero acceleration. So the mass hanger is what? Is 4.2 kilograms. Is 4.2 grams. And then the mass of the crate is constant. So the mass of the crate is constant, which is what? 8.5 kilograms. Okay. And what are we looking for? The coefficient. So for this matter, we know that the static frictional force, F static, okay, moreover maximum, okay, is given by the coefficient which we are looking for times the normal force. This follows very well, but because we don't have the frictional force yet and we want the mu s, we are going to also use the frictional static force, okay, is given by the tension here, this tension T. Now the tension T is equal to the F static. Why? Because the crate is still stationary. still stationary. Okay, now because the crate is stationary, we can say like this. Okay, so for this matter, I'm gonna say that my tension T, okay, tension T equals to the force here also altogether, the force here Fg, this is our tension T here, the force Fg, but this time this Fg should be the mass hanger, okay, the mass of the hanger times 9,8. Okay, 9,8. That's how I find my tension. I can get by saying the 4,2 times 9,8. Now this is the tension in the string here, and the calculator is here. Okay, we can leave it for now. But then also at the same time, I'm gonna say when I multiply the coefficient, okay, times the mass of the crate, okay, times 9,8, okay, also equals to tension, also equals this tension, which is the 4,2 times 9,8. So from here, because I'm looking for the coefficient mu s, okay, I'm going to say the 4,2 times 9,8 divided by what? Divided by the mass of the crate, which is 8,5, okay, multiplied by 9,8. So calculators, what do you get here? Calculators, here I'm getting 0,49. So the coefficient of frictional force is 0,49. 0,49, and does not have units because the coefficient is a ratio between the normal force and the frictional force. That's our answer there. Then 2.3.2. 2.22. What must we get? They say here that now calculate the magnitude of the acceleration represented by y on the graph if the kinetic frictional force between the table is 0,4. So here I'm looking for this acceleration here, y, okay, if the coefficient of kinetic friction is 0,4. So here, now this time, they're giving us the coefficient of kinetic friction, which is 0,4. Note that from our theory, the coefficient of kinetic is less than this one here, which is static, which means we must be correct because this is 0,49, okay? Then they say here, looking for the acceleration, okay? All right, so now this time, the crate is not stationary and the mass hanger is not stationary, so our F net equals to A must be applied from Newton's second law of motion. F net equals to ma. Now here, I'm gonna get the two equations. One equation for the hanging masses, which are moving downwards, okay? Then the other equation is from this side of the crate, which is going to the what? To the right. Okay, so if I start with the crate, I'm gonna say that my T, okay, my tension T minus frictional force is kinetic, okay, equals to ma. But this mass I'm talking about here is mass of the crate times acceleration, okay? So for this case, I'm gonna say also that now the one which is going downwards now, we can say that also the tension T, the tension force T minus Fg, not T, should be now Fg, should be Fg now, right guys? Should be this one now, it is Fg minus what? Minus, okay, what do I do here? Just a minute. All All right. Don't forget we said that F net equals to MA, and we're talking about now the crate for now. So, in this case, don't forget we're looking for the acceleration, but what do we know? That the tension T, talking about the crate, tension T, is, now this F is given by the coefficient, okay, times F normal, that's mass of the crate, together, times 9,8. 9,8 equals to, again, mass of the crate times acceleration. So from here, our tension T is equal, now the mass of the crate we said is 8,5, that's 8,5 times acceleration, which we don't know, then plus the coefficient, they give us 0,4, times mass of the crate, which is 8,5, 8,5, then times 9,8. So we can get our first equation here. It's going to be T, our tension T, equals to 8,5A, 8,5A altogether, and then plus, now when multiply 0,4 times 8,5 times 9,8, it gives us 33,32. 33,32. We're going to say this is our equation 1. Now on the other side now, for the hanging mass going downwards, okay, it is Fg minus tension, okay. Now on the side of the hanging mass is what? It is Fg minus what? Minus tension. So in this particular case, if we still say our F net equals to MA, because it's accelerating as well, it's going to be the Fg minus the tension, okay, equals to MA. Now this I'm talking about the hanging mass. So the hanging mass here is 7,4. We're going to say 7,4 times 9,8, okay, times 9,8 minus tension T, because the string is inextensible, equals to 7,4 times acceleration. So from here, the 7,4 times 9,8, what does it pass? It gives us 72,52. So 72,52, and then minus 7,4a minus 7,4a should give us the tension. So we have two equations now. This was equation 1 here, and this is now equation 2. Now the string is inextensible. It means that the equation 1 should equal to equation 2. It must be the same tension. So I'm going to say that 8,5a plus 33,32, okay, should be equal to what? Should be equal to 72,52, okay, minus 7,4a. 7,4a. If I collect like terms here, I'm going to have, when I add the 8,5a and 7,4a, I get 15,9a. So this is 15,9a, 9 times acceleration. Then the 72,52 minus 33,32, it gives me 39,2. 39,2. So my acceleration, when I divide the 39,2 by 15,9, it gives me 2,47. So this is 2,47. 2,47 meters per second squared. That's how here. Hope guys we are together. That was question 2.3.2. Now they say here that A 5 kg block is now placed inside the crate and the experiment is repeated. How will this affect the maximum static friction force now experienced by the crate? Choose from increases, decreases, or remain the same. Give a reason for your answer. Now, when we add a 5 kilogram block on our crate here, this crate here, it means we're going to be having the first plus a 5. Né? So, we're increasing on the weight. And so, because of that, the frictional force will increase. So we say it increases. Now they say give reason for your answer, because our frictional force is proportional to the normal force. Okay, normal force. And because we're increasing on the mass, then normal force will increase. So the normal force will increase. So because normal force will increase, then likewise, even the frictional force must increase. All right. Thank you so much for watching. Don't forget to like, subscribe, and share the video to your friend. See you in our next video. Bye-bye. Oh yeah, you're welcome once again. I will not get tired of telling you this. Like I said, please, you can pause the video now and you try out the question first. Okay, when you are done, then you can replay the video and mark your work. Okay, all right, this is May, June 2024. As you see it here, question 2. Block A of mass 4,1 kg is connected to a block B of mass 2,3 kg by a light inextensible string passing over a frictionless pulley. Then block A is at rest on a rough horizontal table and block B hangs vertically as shown in the diagram below. Okay, then a force F of magnitude 49 newtons is applied on the block A at an angle of 50 degrees, you see it here, to the horizontal, causing block A to accelerate to the left. This is to the left, né? Going where? To the left, together. And then they say from resting along the table. The coefficient of kinetic friction between the surface of the table and block A is what? 0.35. Then they say here that now, what must we do? They say, state Newton's second law of motion in words. We said that when a net force acts on the body will accelerate in the direction of the net force, with the acceleration directly proportional to the net force and inversely proportional to the mass of the body. 2.2. What did it say here? 2.2. Now they say, draw a labeled differential diagram showing all the forces acting on block A while it accelerates to the what? To the left. Ne? Okay. Now they're giving us 5 marks here and they want a table diagram. Okay, so this is 2.2. Now, if you look at A, this one here, it's on the surface and exerts the weight. Okay, the weight Fg. And being on the surface, we have what? The normal force, which is pointing upwards, okay? And then, besides that, we have other forces acting on this same block, like we have the tension force, okay? Tension force. Then we have because it is going to the left, there's frictional force here, which is opposing, but because it is in motion, we call it kinetic frictional force. And then we have the applied force at an angle, and being a free body diagram, the dot, so the applied force here, the 49, must be put there as well. If you check here, these are the 5 arrows, meaning x. Okay, so here we go. You're gonna say that we start with the normal force together with what? With the weight. okay, like this. Then put them here. Okay, we put them here. And then, like you saw already, that we are having the block going to the what? To the left. So we have the applied force here at angle, okay, at an angle. And being a free body, they want it to be starting from a dot. Now the free body diagram starts with a dot, this applied force here. Now this applied force is opposed by the two forces. That's the tension force together with what? With the frictional force. So the tension force here is opposing the motion, okay? And because the body is going to the tension force is pulling, you see it is pulling to the right, né? Then together with what? Together with the frictional force, okay? The frictional force here. Now this you see in the red is the frictional force. And because the block is moving, we call it what? We call it kinetic frictional force. And because we want a free body, we represent it with a dot, okay? So put a dot here. Dot now shows what? Shows us the free body, okay? Now this diagram must be labeled. So here we have the normal force, which is F normal, okay? And then we have the applied force, which is 49 at an angle. If you know the value, just put 49. Or you can say FA, meaning F applied. Then we have the tension force T here. Then we have the kinetic frictional force, okay? Then we have the weight, which we call Fg in this case. Hope we are together. Then they say, after doing the double diagram, that what must we do next here? They say calculate the magnitude of the frictional force exerted on block A. Now guys, listen carefully here. I'm looking for the kinetic frictional force on block A. Now listen carefully here. Now to get our kinetic frictional force on block A, it depends on the given information. If I know the coefficient, like in this case, then I'm going to use, so this is 2.1. I'm going to use what? The kinetic frictional force Fk equals the coefficient of kinetic friction, then times normal force. So once I get the normal force, I just substitute here and I get my what? My kinetic frictional force. Hope we are together, okay? So from here, however, if I don't have the coefficient, then I'm going to be having the bodies in motion, okay, all having the tension. Then I can say that they're going to be equal. That would be actually, if it is stationary, it's going to be called the static frictional force. But lucky enough for this question in May, June 2024, they gave us what? The coefficient. Now our force, this one which is pointing up, you can see it here. Now this force at an angle has got components. It's got components here. There is a point which is acting to the left like this, okay? That is Fx. That is Fx, okay? And then another component is acting vertically upwards, and that is the vertical component, which you call Fy. Now the two components, Fx and Fy, they are perpendicular to each other, okay? So this is our Fx, this is our Fy, okay? This is our Fy. Now they are perpendicular to each other. Now if you look at my diagram carefully here, you can see that the normal force, the F normal, okay, the F normal together with the Fy, they are pointing upwards, né? And so they must be equal to the Fg, which is pointing downwards because the block is not moving up or down, okay? All right, so now in this case, my F normal is equal to Fg, that is mass of the block, which is 4,1 times 9,8 times 9,8, and then minus the Fy. Now this angle here is 0, okay, it's 50, and because Fy is opposite, I'm going to use sine. I'm going to use sine of 50. So this is 49 times sine what? Times sine of 50 degrees, okay? Sine of 50 degrees. So here, calculators, what's your normal force? What did you get there? Here, my calculator, it gives me the 2,64. 2,64 as my normal force. After getting 2,64, don't forget we're looking for the frictional force, that is kinetic frictional force, given by the coefficient 0,35, like they said there, 0,35 multiplied by the normal force, which is 2,64, and the calculators, what do you get there? Here, I'm getting 0,924, 0,924, 0,924 newtons. So, because you give answer to the small places, Fk equals to 0,92 newtons. That was question 2.3.1. Then they say here, next, that also get what now? They say, calculate the magnitude of the acceleration of block A by applying Newton's second law to each block separately. Okay, so now because the blocks are joined by the inextensible string, we have the tension. We have the tension, okay? And because the blocks are going to the what? The blocks are going to the left. I mean, this one here, the block B will be moving upwards, and then block A will move into the what? To the left. So, for our question 2.3.2, talk about F net, okay, equals to MA, and I start with block what? With block B. Block B, I see that my tension T minus Fg equals to MA. My tension T minus Fg equals the mass of block B times acceleration. So I'm going to say tension T minus 2, T times 9,8, okay, equals to 2,3 multiplied by what? By acceleration. Okay, so from here, my tension T is equal to what? My tension T is going to be the 2,3A, then plus what? Calculators, the 2,3 times 9,8. What does it give you? Here it gives me 22,54. 22,54. And so this is equation 1. Now if you talk about block A, with block A now, because it is moving to the left, okay, my Fx, so if you check here, my diagram here, my Fx, this one here, the Fx, okay, minus Fk minus T equals to MA, okay, the Fx minus Fk minus T equals to MA. Hope we are together. The whole component, which is Fx minus tension force minus kinetic frictional force equals to MA. But this time we talk about block N, so A here. So the fx, because it's horizontal, we're going to use 49 and then cos of 50 now, cos of 50, okay? Then minus tension T. Now frictional force, I got it already, 0.92. Hope you remember to see this one here, 0.92. So minus 0.92 is equal to the mass of A, which they gave us as what? The mass check here, the 4.1, okay? That is 4.1 times A. That is 4.1 times acceleration. So from here, if I simplify here, the 49 cos 50 minus 0.92, what do I get? Calculator, what do you get there? Here I'm getting 30,573. I'm getting 30,573. So this is 30,573, and then I'm gonna say minus 4.1a equal to our tension T. So this is equation 2. Okay, so now because the string is inextensible, okay, I'm gonna say equation 1 equals to equation 2. Equation 1 equals to equation 2. And for that matter, I'm gonna have the 2.3a, okay, and then plus 22.54 plus 22.54 should be equal to the 30.573, and then minus 4.1a, minus 4.1a, minus what? Minus 4.1a. Now if I click like times here, I'm getting my acceleration, okay, equals to 8.033, okay, divided by 6.4. And then lastly, my acceleration equals to 1.26 meters per second squared. And because they said they want magnitude, they don't want direction. Okay, hope we are together. So say next says what here? That's all right here. Okay, so thank you so much for watching. Catch you in our next video. Don't forget to subscribe and share and comment and like the video. Bye bye. Oh yes, this is November 2023. Yes, again one more time, like we said, you can pause the video and do the question first. Then after doing the question, you watch the video to mark your work. Oh yes, this is Patrick Kamala, tutor, educator, online for State College Polokwane. Yes, and then for more information, you can get us on 0785 222041. Let us start now. This is question 2, November 2023. It says here, the two blocks A of mass 4 kg and a B of mass 9 kg, they are connected by a light inextensible string. The blocks are held at rest on a plane which is inclined at an angle of 35 degrees with the horizontal. Then they say a constant force, this force here, acting parallel to the plane is applied to the block B, on block B here, as shown in the diagram below. The blocks now accelerate up the plane at 2 meters per second squared. So this time they've given us acceleration, which is 2 meters per second squared. In the previous questions which we did now, remember that they always gave us the speed. And because of that constant speed, acceleration was 0. But now, acceleration is 2 meters per second squared. So take note of that, okay? And then I repeat, to the two blocks, A of mass 4 kg and B of mass 9 kg, they are connected by a light inextensible string, okay? If we say inextensible, we mean that it is not elastic, and so the tension is uniform. Then the blocks are held at rest, okay? They're not moving, held at rest on a plane which is inclined at an angle of 30 degrees with the horizontal, okay? Then a constant force, this force here, a constant force acting parallel to the plane is applied to block B as shown in the diagram below. Then what happens? The blocks now accelerate up with acceleration of what? 2 meters per second squared, 2.1. State Newton's second law of motion in words. We said that when a net force acts on the body will accelerate in the direction of the net force, with the acceleration directly proportional to the net force and inversely proportional to the mass of the body. Now they say kinetic frictional force acting on blocks A and B. For A, it is 5,88, and then for B, it is what? For B, it is 13,23 newtons, okay, respectively. Then they say draw a labeled free body diagram showing all the forces acting on block A. So if we talk about a free body diagram, okay, then we should have the arrows coming from the dot. If you look at our marks here, there are 4 marks, so there must be 4 arrows coming from the dot. So now don't forget that here we have the incline like this, and so the body is on the incline, which is like this here. So what do you expect now? We're going to be having the frictional force, which is bringing down, but I said it's accelerating upwards. So because of this upwards acceleration, it means that we have the force F pulling the block. So for this matter, mean that we're going to have our free body somewhere here, okay, somewhere here. Then this free body, now the surface exerts a normal force. Now the normal force must be normal. Now the normal in mathematics we mean must be perpendicular, so must be like this. When you come here now, it should be perpendicular to the what? To the surface, called normal force. And then we have another force which is acting vertically downward, that's the force of gravity. And you see here on our block energy, the force of gravity is like this, acting downwards. So in this case, we're going to bring it here on our free body, and the base vertically downwards, okay? This is our gravitational force or weight, Fg. All right, that's what we have here. So we said we must label the free body diagram. So, and this is the normal force, which is F normal, okay? And then this one is the tension. This is now the tension, okay? The tension. This one is the weight, which we also call Fg, okay? This is our frictional force. Because they said now the body is moving, kinetic frictional force, okay? Then they say here 2.3, calculate the magnitude of the tension in the string. Okay, the tension in the string. Remember that this body is accelerating upwards, and so because of that, we're going to use Newton's second law of motion. Okay, and we say that our F net, or our net force, equals to mass times acceleration. Okay, so for this matter, now because we're talking about the tension, for block A, the tension is pulling up like this. So opposed by what? By Fg parallel and frictional force. So we're going to select here that our tension, okay, minus frictional force, that is kinetic, block A, all together, and then minus Fg parallel equals to MA. Let us now substitute. We're looking for this tension in the string here. So our T, now the FK is 5,88. We say here 5,88, okay? Then FG part is going to be mg sine, okay? But the M is 4. What about G? 9,8, okay? And then sine of which angle? Sine of, they gave us 35. Yeah, sine 35. Sine 35 degrees, sine of 35 degrees. And then equals to MA. The mass is 4. They gave us acceleration, which is 2. So from here, when you simplify this, our tension from our calculator here, it gives us 36,36. So we have 6,36. This is 36,36 newtons. Because they say the magnitude, they don't want direction. So that is 2,3,1. Now the 2,3,2 force F. Now talk about block B. So for block B, we get to our F net equals to MA. Our F net equals to MA. So for block B, our F net equals to MA. You're gonna say this now 2,2. If we say F net equals to MA for block B, what do you think we are gonna do here now, guys? Okay. Now it is the force F, this one, which is pulling the block B opposed by the tension. Now the tension on block B is upwards. Okay. Now the force is acting upwards, but the tension acting downwards, together with what? With the frictional force. Okay. This is FK, but for block B. So it's gonna be our force, which we are looking for, all together, and then opposed by what? The tension and frictional force. Going to be the force F minus the tension minus frictional force on block B, on block B equals to MA. Now that we know the tension already, we can now substitute. So our force, which we don't know, okay, minus the tension, which is 36,36, okay, 36, then minus frictional force, which is 13,23, okay, and then equals to MA. The mass is 9 here, and then times 2. So when you simplify this on here, our force on the calculator here, it gives us, I forgot something here, sorry. So this one should be minus FG parallel, okay? Minus what? Minus FG parallel. So here, I should have said minus FG parallel. So minus FG parallel, okay, then equals to MA. Now we took down the force applied minus tension minus friction minus FG parallel, okay, equals to MA. So here I'm gonna say also minus, now FG parallel here is mg, that is 9. The mass here is, the mass is 9 here, this 9 here, okay, so minus 9, then times 9,8 times 9,8, right? Sine of 35, sine 35, okay, and then equals to MA equals to 9 times 2. 9 times 2. So from here, I'm going to simplify this now on the calculator here. it gives me 118, 180 newtons. That's our force here. I hope guys we are still together. They say here next that 2.4, the angle that the plane makes with the horizontal is now decreased. How will this is now decreased? Okay, is now decreased. How will this change? How will this change the kinetic frictional force acting on block A? Okay, choose from increases, decreases, or remains the same. Now, if this angle of inclination is decreased from 35, maybe somewhere here now, in this particular case now, our FG perpendicular will do what? Will increase. And so, our normal force will increase. And so, because normal force increased, it means that the frictional force is going to increase. So here, what do we say? That first of all, when we decrease the angle, okay, when decrease our angle, okay, the normal force that is from FG perpendicular, so the F normal increases, okay, increases. Now, when the normal force increases, what do we know? The frictional force, F kinetic, is proportional to the normal what? To the normal force, to the F normal, okay? And so because normal force increases, then therefore, the friction force must increase. The frictional force will increase. The frictional force will do what? Will increase. I hope guys we are together, okay? Alright, thank you so much for watching. Don't forget to share and like and comment on the video. Bye-bye. Oh yeah, once again you're welcome to our session today. This is Patrick Kamala, tutor, educator for mathematics and physical science, 8 to 12. Now in this here, we're going to look at the November 2023, May, June. And like I said, please, you can pause the video and try this question out. When you are done, then you can mark your work. All right. It says that block A of mass M, this one here, is connected to block B of mass 7.5 kilograms by a light inextensible rope passing over a frictionless pulley. Then block B is initially held at a height 1.5 meters above the ground, while block A is initially stationary on the ground, as shown in the diagram below. Now, when the block B is released, it moves vertically downwards and strikes the ground with a velocity of 3.41 meters per second. Ignore the effects of friction. They say 2.1. Show by means of a calculation that the magnitude of the acceleration of the block B was 3.88 meters per second squared, while the block was moving vertically downwards. Okay, I repeat one more time. Block A of mass M is connected to block B of mass 7.5 kg by a light inextensible rope passing over a frictionless pulley. Block B is initially held at a height of 1.5 meters above the ground, while block A is initially stationary on the ground, as shown in the diagram below. We can see that here. They say when block B is released, it moves vertically downwards and strikes the ground with a velocity of what? 3,41 meters per second. They say ignore the effects of air friction, then show by means of calculation that the magnitude of the acceleration of block B was 3,88 meters per second squared while the block was moving vertically downwards. Now you see there is a rope here, and then the block here is being pulled down by Fg, but because we have got the tension, it means that it's not in free body, it's not in free motion, free fall. Okay, so and I'm looking for the acceleration while it is in motion. Okay, so if I look at if I consider block B, okay, this block B here, this one here, and I choose down as positive, okay. If I choose down as positive, if I choose downward motion as positive, and then I see initially V initial is 0, starting from rest, okay, from rest here. We're talking about block B, don't forget block B. V initial is 0, and then final velocity here, final velocity. Okay, so we are saying that in this case V initial is 0 because it was held stationary, and then when you're hitting the ground, the velocity is what? They say it is this one here, the 3,41, that is V final, okay. V final is what? Is it 3,41 meters per second, and then the change in y for this block of B when hitting the ground, it is 1,5 meters. So our change in y is 1,5 meters. 1,5 meters. Okay. All right. So I want to show that acceleration during motion is what? It is the 3,88. Okay. So here I'm gonna use the motion. I'm gonna use V final squared. V final squared equals to V initial squared plus 2a plus 2a, then change in y, okay, change in y. So in here, I have the V final, that is 3,41 squared, okay. V initial was 0, so 0 squared here, then plus 2. Now acceleration here, it is not 9,8 because of the tension here, which you see in the string. So it means I'm looking for the acceleration, and then times change in y, which is what? Which is 1,5. 1,5 here. Okay, so from here, my acceleration will be given by 3,41 squared divided by what? By 3, which gives us what? Which gives us 388 when you round off from a calculator here. So this is meters. But that's our first question, which is 2.1. Okay. Then 2.2 here. What do they say? Draw a labeled diagram showing all the forces acting on block B immediately after it was released. Okay. Now this block B, upon it being released, it's gonna go down and opposed by the tension. So in other words, the free body diagram like this now. I'm having one force pulling up, and the other is taking it downwards. Okay. So in this case, it means that I'm gonna say, because it's going downwards, I'm gonna put my free body somewhere here. Okay. And then because of Fg, the force of gravity, okay, and then it's opposed by the tension, the strain. That's our 2.2. Then they said 2.3, state Newton's second law of motion in words. We said that when a net force acts on the body will accelerate in the direction of the net force, with the acceleration directly proportional to the net force and inversely proportional the mass of the what? The mass of the body. Okay. Next question here, 2.4. They say, calculate the value of m by applying 22nd law to each block while they are in motion. I need the mass m. This mass m here is what I'm looking for while they were in motion. Okay. So they are in motion. I'm gonna use what? I'm gonna use Newton's second law of motion. No wonder they asked about it already. This is tension here. When tension is going up, now your tension will be going up here. And this one is going to be being opposed by what? By Fg. Okay, so we're doing now 2.4 here. 2.4. If I say F net equals to MA, F equals to MA, and I talk about block B, okay, block B. So for block B, as you see, it's going downwards, ne? So I'm going to say Fg was going downwards like this, and then A is going upwards like this, okay? So the Fg minus T, the Fg minus T equals to MA, okay? So in this particular case, I'm going to say the Fg is mg, that's 7,5, okay? That is 7,5, ne? 5 times 9,8 times 9,8, and then minus the tension T, which I don't know, equals to m, that is 7,5a. Hope we are together. So from here, if I simplify this, 7,5 times 9,8, I get 73,5. So this is 73,5, ne? And then I can say minus 7,5a, 7,5a equals to T. I can say this is equation 1. Okay. Then, if I look at now my block A is going upwards. F net equals to M, but the tension T minus Fg, okay, minus Fg equals to MA. Now, those of you who wonder how I get my equations, like here, you see the block was going up on it. If the block was going up, the forces which are pulling upwards are going to be positive. The forces downwards are going to be negative. That's why I have the T minus Fg here. That's how I get it, ne? The T minus Fg. Okay, so let us now substitute. Let us now substitute here. So the T, I don't know the T yet. Don't forget that. And because I don't know the T yet, yes, for block A, ne? For block A, because it's going up, so T minus Fg equals to MA. Now, let us substitute like we said. Our T, we don't know yet, okay? Then the Fg is mass times gravity, and that's 9,8 times the mass we're looking for. Okay, so times 9,8, and then equals to MA, but the M we don't know. Okay, that's going to be M times A. So from here, we can set our T equals to MA plus what? Plus 9,8M. Plus 9,8M. Okay. And so this is equation what? Equation 2. Okay, so from here now, Because the two equations are all tensions, you can say equation 1 equals to equation 2. 1 equals to 2. By the way, we have the acceleration. Better put it here. So I'm going to say that our MA plus 9,8 m, okay, 9,8 m is equal to equation 1, which is 73,5, okay, 5 minus 7,5a. Okay, so now I'm looking for m, okay, but I know which is 3, some they said here, 3,88, okay. So when I put it here, the 3,88, it makes my things simple. So here we're gonna say 3,88 m, then plus the 9,8 m equals to 73,5, okay, minus 7,5. Now the a is 3,88, okay, 3. All right, so from here, when I simplify here, I'm gonna get my m. I'm gonna get my m here. So finally, as if I subtract here, then I divide by this one here, I'm getting my m at 3,25 kilograms. That's our m here. The next question here, what do they want now? 5. Calculate the maximum height above the ground reached by block A. Now, maximum height reached by block A. Now, don't forget that when this block B hits the ground, block A is somewhere here, all together. So, when block B hits the ground, then it means that we no longer have the tension acting on the what? On block A. So now block A is going to be in free fall. But at that particular time, they have the same velocity. I repeat, when block B hits the ground altogether, maybe block A would be somewhere around here. Okay. I mean somewhere around here. Somewhere around here. Our block what? Our block M, block A, somewhere around here. Okay. And then it's going to continue going upwards because of the initial momentum, okay. So now as it moves up now, we know that in this particular case it's going to go up because of what? The initial force or the initial momentum. Now we say it's going to be in free fall, okay. Going to be in free fall, okay. So now for that matter, what I'm going to do, I'm going to get the maximum height reached by the block A from this particular point. Okay. Then I'm going to add the 1,5, and so I will have the answer which they want here. Because they said that calculate the maximum height above the ground reached by block A. And so because of that, I'm going to use what? I'm going to use projectile motion, okay? So I'm going to say that my B final, okay, B final squared is equal to V initial squared equals to V initial squared plus 2A change in Y, okay, plus 2A change. So in this particular case, now when which is maximum height, velocity is 0, né? So it's going to be 0 squared here equals to the V initial. Now this V initial is the same velocity here, which is the 3,41. Somebody can say why? Because it makes sense. The blocks were together, so and they were attached with a string, and when the block hit the ground, this velocity for block B, so velocity for block A, because they were stuck together, you know, by the rope. Okay, so I'm gonna put here 3,41. 3,41. Don't forget must be squared. Then plus, okay, plus 2a plus 2a. This is the 2 here. Now here I'm going to have 9,8, okay? 9,8. And because it's going upwards, and I chose down as positive, and I chose up as positive, so negative here. So this is, if I simplify here, I'm going to get with the calculator my change in y, okay? My change in y is equal to 3,41 squared divided by what? By 19,6. 19,6. Now, calculator, what do you get? Here I'm getting 0,59. So this is 0,59. 0,59 meters. So that is the extra height when the block B hit the ground and then block A continued upwards. But because I want above the ground, therefore the maximum height, or H maximum, by block A is going to be the 0,5 meters, okay, plus the original 1,5 meters when it was still connected with block A. Okay, so here the total is going to be here 0,59 here, beg your pardon, 0,59 here. So when I add these two now here, I am getting 2,09 meters above the ground. All right, thank you so much for watching. Catch you in our next video. Don't forget to share, comment, and like the video. Bye-bye. Oh yes, November 2022, question 2. Question 2. A crate P of mass 1,25 kg is connected to another crate Q of mass 2 kg by a light inextensible string. The two crates are placed on a rough horizontal surface. A constant force F of magnitude 7,5 newtons acting at an angle of theta to the horizontal is applied on crate Q as shown in the diagram below. The crates accelerate at 0,1 meters per second squared to the right, okay? They say here that crate P experiences a constant frictional force of 1,8 newtons and the crate Q experiences what? 2,2 newtons. 2.1. State Newton's second law of motion in words. We said that when a net force acts on the body will accelerate in the direction of the net force, with the acceleration directly proportional to the net force and inversely proportional to the mass of the body. Then 2.2, draw a labeled free body diagram. Okay, so here we are done. We are here now. Label the free body diagram for crate P. Now our crate P here, as you can see, it's on the surface and pulled by the tension in the string, opposed by friction at surface exerts normal force. So you're going to be having the 4, because these are 4 marks here, you're going to be having the 4 arrows all coming from the dot. Okay, so this is what we have here. We have the 4 arrows all coming from the dot. Okay, and then this one's here as well. Now these arrows, yeah, we have them like this. So our block P, because we want the free body, we're going to put a dot in here to show free body. Normal force F normal on block P. Okay, And then here we have the weight Fg. Then we have the tension in the string, and then frictional force, which is opposing the motion. Okay. Excuse me. And then they say 2.3, calculate the magnitude of the tension in the string. Looking for this tension in the string here. Now, because P has only two forces acting directly, we better use that one. So you're going to say that our 2.3.1, I'm going to use F net equals to MA. If I use F net equals to MA, okay, and I look at my block P. So for block P, the tension, okay, the tension minus frictional force for block P equals the mass of P times acceleration. Looking for this tension here. Now the frictional force here, they gave us 1,8 here. You can see that 1,8, okay, and then the mass is 1,25. 1,25. What about acceleration? They gave us 0,1, okay? So times 0,1. In this case, my tension, if I simplify here, it becomes 0,125 plus 1,8, which gives me my final answer as 1,93. So 1,93 is our tension, here. Okay, so in this particular case, now they say next question here that the angle theta. We want our angle theta here. Now this angle theta is what we're looking for now. So we check what we have here. Our crate Q is pulled to the right by the horizontal component Fx. So we can say in that case that our F net equals to MA again, okay? Our net force, our F net to MA, F net equals to MA, but then this time it is the horizontal component here, which I'm going to call Fx, okay? So it is Fx, okay, component Fx, then minus the tension in the rope, then minus frictional force, kinetic for what? For Q, okay, equals to mass of Q, okay, and then times acceleration. Okay, so here, now our Fx given by the 7, because it is adjacently, is given by the 7,5, 7,5 cos of theta, minus the tension which you got as 1,93, okay, minus frictional force in Q, which is 2,2 here. They gave us 2,2, and then equals to 2 multiplied by what? By 0,1, okay? So in here, our 7,5 cos theta, when you simplify here, we're going to get because it's plus 2,2 plus 1,93, it gives us 4,33, and so our theta cos inverse, okay, equals cos inverse of this one here, which is the 4,33 divided by what? By 7,5. Okay, so calculator, what do you get here? Calculator. So our theta, calculator here, I'm getting 54,74. So this is 54,74 degrees. All right. Thank you so much for watching. Don't forget to share, subscribe, and like the video. Bye-bye. Oh yes, great help. Hope you're doing good. Yeah, this is Patrick Kamala, tutor educator, mathematics and physical sciences, grades 8 to 12 online. Okay. Alright, now this question is May June 2022, and this question 2, it says, a man faces difficulty while swimming in a dam during the rescue operation. An inflated tube attached to a helicopter by a rope is dropped from the helicopter. The man of mass 70 kg holds onto the inflated tube of mass 4 kg while the helicopter is flying horizontally at a constant speed. An average friction of force of 300 newtons is exerted on the main tube combination while they are dragged horizontally along the surface of the water by the helicopter. The rope makes an angle of 50 degrees with the surface of the water as shown in the diagram below. Assume that the rope is inextensible and massless and the water of the dam does not flow. So this is the helicopter here, this is the main tube combination, this is the rope at 50 degrees. They say state Newton's first law of motion in words. One more time. A man faces difficulty while swimming in a dam during the rescue operation. An inflated tube attached to a helicopter by a rope is dropped from the helicopter. The man of mass 70 kg holds onto the inflated tube of mass 4 kilograms while the helicopter is flying horizontally at a constant speed. An average frictional force of 300 newtons is exerted on the main tube combination while they are dragged horizontally along the surface of the water by the helicopter. The rope makes an angle of 50 degrees with the surface of the water as shown in the diagram below. Now they say state Newton's first law of motion in words. How do we state it? We say that a body will remain at rest or continue moving at a constant velocity unless it is acted upon by an external force. Then 2.2, draw a free body diagram of the main tube combination while they are being dragged. Okay, so now here, you see we have frictional force, right, guys? So we have got frictional force, and then we have the main and the tube combination. The mass for the main is 70 kg, and the tube is 4 kg. Okay, then we have this rope here. So there is a tension in the rope here, right? Tension in the rope here, and then the main exerts what? The weight together with the tube combination. That's our Fg. Because it's going this way, then the frictional force must be opposing motion this way. Okay, and then because of the frictional force, we must be having a normal force here by the surface. So this is F normal. So meaning that our question 2.2 would be like this. So we have the weight together with the normal force opposite each other. Okay, like this. The weight of the main and the combination opposite each other like this. Okay, that's what we have here. And now we have the frictional force which is opposing. Okay, and then we have what? Then we have the tension in the rope. Okay, the tension in the rope. Now this tension is in the rope here, and as you can see, it is facing like this. Okay, it's facing at an angle. So this is the tension in the rope. Okay, And you see they gave us 4 marks, meaning we should be having 4 arrows. Okay, should be having 4 arrows. Okay, so now because of the free body, we show it by using a dot here. So this big dot shows the free body. So now what we see here is our normal force. It is F normal by the surface of the water. This is the weight Fg, the weight Fg. This is the frictional force, okay? And what's moving, call it kinetic frictional force. And then this is the tension in the rope, okay? That is it there. Then they say that now calculate the tension in the rope. That is 2.3, the tension in the rope. Now this combination was moving at a constant velocity, and so for that matter, our F net, okay, our F net equals to MA equals to M. But then because of the constant velocity here, they said the constant speed, so it means our F net equals to 0. Okay, so in here, now this tension here has got 2 components. We have the horizontal component, okay, horizontal component here, this one, get his point here, coming here, and then we have the vertical component as well. This is the vertical component here, which you see in green color, this one. Now the 2 components, horizontal and vertical, must be what? Perpendicular to each other. Okay, so as you can see, this component going to the left, I'm gonna call it Tx, okay, and this component going up, we call it, okay, Ty, but the angle here they gave us is 50 degrees, okay, so this is 50 degrees here. Now because the helicopter is going to the left like this, our F net given by the Tx, okay, Tx minus the frictional force equals to 0, okay, equals to 0. So in this case, our Tx equals to what? Equals to the frictional force, which is Fk, and then, but from the triangle here, our T is the same as T cos of 50. That's a tension times cos of what? Cos of 50. Hope we are together here. And then the frictional force given to us, they gave us 300, so equals 300 here. So now because we're looking for the tension, so our tension T equals to the 300, okay, divided by what? By cos of 50. Cos of 50. So which answer do we get here? Which answer do we get here? Calculators. Here I'm getting 466.72. 466.72. 466.72 newtons. That's our tension there. Then they say how will the answer to question change if the helicopter accelerates while dragging the main? The frictional force and the angle between the rope and the surface of the main remain the same. Choose from increase, decrease, or remain the same. Now remember at first it was a constant speed, whereby it was zero acceleration, but now the helicopter is accelerating, which means acceleration is no longer zero. So because of that, we're going to say it increases. Why? Because F net is not equal to 0. Net force, because our net force is now bigger than 0. It's no longer what? No longer equal to 0 like you see in this other case here. Okay, that's why the tension will increase, because now the net force is bigger than 0. Okay, so next question here, they say another rescue operation the inflated tube of mass 4 kg dropped from the stationary helicopter, and it strikes the water at a speed of 16 meters per second. The tube sinks vertically downwards into the water to a depth of 0.8 meters and then rises to the surface. The rope hangs loosely. This is the main here. This is now the tube we're talking about. They're saying that it drops on the surface of the water with a speed of, then it goes down to a depth of 0.8 meters. Okay, 0.8 meters, and then they say calculate the magnitude of the average upward force exerted. So we need this average upward force, okay, exerted on the inflated tube while it is sinking. Assume that the average upward constant. Okay, now here that is 2.5. That is 2.5. We're looking for the average upward. So if I talk about my F net equals to MA Now this tube is going down, right? Now as it goes, why is it going down? It's going down because of the what? The FG, right guys? Because of FG. Now although it's going down, it is being pushed upwards by the average upward force, which I'm going to call F word. Okay, so from here I think that our FG, you see it is acting downwards, né? So our FG, right, minus the upward force, that's going to be FUP, upward force, equals to MA. So in here, they give us the V initial when you're striking the surface of the water. It is they want the 16 meters per second. That is 16 meters per second, and because it stops at a height of 0.8 meters downwards, that means that's where it is. It sinks until that height. Meaning our final velocity today is what? Is 0. Okay, so V final is 0, and then the change in Y or height is 0.8. Okay, so now because of this acceleration here, we need to first find the acceleration by using V final squared, V initial squared, okay, plus 2a, and then change in Y. Okay, so here, now V final here, we say it is 0. Let's say 0 squared here. And then the V initial, it is the 16 when you're striking the water surface, 16 squared here. Then plus 2, looking at then times 0.8. Okay, so here, our acceleration, if we compute this one here, it's going to be negative 16 squared, okay, divided by what? By 2 times 0.8. So here, with my calculator here, I'm getting what? I'm getting the negative 160 meters per second squared. Negative 160 meters per second squared. Okay, so now after getting acceleration, now I come back to get my upward force from this equation here. I'm going to call it equation 1. Okay, so FG, remember we're saying it is FG minus upward force. Okay, upward force equals to MA. Let us now substitute here. Now the mass is 4, kilograms times 9,8. Okay, we're looking for this upward force. So upward force. Now we have the acceleration going to be say 4 times negative 160. Okay, so from here we're gonna say 4 times 9,8. Okay, then plus 1 plus what? Plus 4 times 160 should give us what? Should give us the upward force that we're looking for. So from here, calculators, what do you get? The upward force. Okay, so here from my calculator, getting 679,2. 679,2. 679,2. That's our average force, the upward force. Okay. All right. Thank you so much for watching. Catch you in our next video. Bye bye. Oh yeah, this is 2021 November. 2021 November. Question 2. It says a 20 kilogram block is placed on a rough surface inclined at 10 degrees horizontal, and a constant force F acting parallel to the surface is applied on the block so that the block moves up the incline at a constant velocity of 2 meters per second. Refer to the diagram below. And then a constant kinetic frictional force of 8 newtons acts on the block. Okay. State Newton's first law in words. A body will remain in its state of rest or continue moving with a constant velocity unless a non-balanced force acts on it. Okay. Then they say 2.2, draw a labeled differential diagram for the block. Okay, so here, as you can see, the surface is the incline here. Okay, we have the force F. So, because we have got frictional force, that force F is opposed by frictional force. Next, so we're going to have our this now. Okay, it's going to be like this now. This one. Okay, so we have this one. So we are having the frictional force. Save. Okay. And so, yeah. So here we have the applied force, which is the force F, which is pulling upwards. Okay. And then now, being on the surface exerts a normal force. The normal force must be the surface, don't forget. Must be what? Perpendicular to the surface. In this case, it will be like this, okay? And then it has got weight, is because of 20 kilograms. Okay, so now the weight, it is down here. That is Fg, which comes down like this now. That is it now. That's our free body diagram. Don't forget the dot. The dot shows us what? The free body. This is our F normal. We can call it normal force. Okay. Normal force. And then this that force F, applied force F. Okay. This is our weight, which we'll call Fg. Then here we have force kinetic because it is moving. Okay. That is 2.2. Now they want the force F, okay, the constant velocity here, our F net equals to 0, so you're going to say here That's 2, 3, okay. Our net force equals to 0, equals to MA, which equals to 0. Okay, so for that matter, we substitute. So we substitute here. Now the net force here, it means the force F minus Fk equals to MA, in this case, which is going to be 0. Okay, but now we know something else here, that the net force is actually going to be that force F, which is going to, okay, and then minus what? Minus frictional force. But more to that, this one has got a component, ne? This component which acts parallel to the slope, which we call FG parallel, ne? This FG parallel. Then we're gonna say here minus FG parallel is acting down the slope, okay? Then equals to 0. From here, they give us a frictional force, so our applied force equals to frictional force, that is Fk, then plus Fg parallel, plus Fg parallel. Okay, so here it's going to be the 18 newtons plus, how do you find Fg? It is mg sine, okay, mg sine of 30, Now that we know the mass, they gave us what? They gave us the mass of 20, maybe 20 times 9,8, okay, and then sine of what? Sine of 30. Which answer do you get, calculators? What do you get here? So here, it gives me 116 newtons. 116 newtons. Okay, and because they say the magnitude, they don't want direction. Otherwise, I was going to say upwards. But the question talked about magnitude, so they only want the size. Okay, that's our 2.3. And I hope we are together. Then they say that the force F is removed when the block reaches point X on the surface. The block on the surface to rest immediately at point Y. Assume that the kinetic frictional force acting on the block remains 18 newtons as it moves from point X to point Y. Write down the net force acting on the block as it moves from point X to Y. Now, initially, point X, the block was being pulled by the force F, and then our net force was going upwards. But when we reach point X now, they remove the force F. You see that? They say that the force F is what? The force F is being removed. The force F is being what? Removed. When the force F is removed now, they set down the net force. Now, because it's gonna now, remember this is 2 meters per second at this point. Okay, because they said constant velocity. This is 2 meters per second. 0 here. Okay, now why does it become 0 now? Because now the net force is now acting in the opposite direction, and because it begins from 2 to 0, it's going to be the negative of 116, but because of that negative, we say that our answer now is going to be 116 down the slope, or you can say downwards. So it's going to be here 116 newtons, okay, down slope, or you can say downwards, meaning opposite direction, because it is changing from 2 meters per second to 0. Then they say here, calculate distance between points X and Y. Now to get that distance here, don't forget that in this case, V initial is what? It is 2 meters per second, which was the constant velocity. Are we together? And then coming to 0, V final is 0, okay? V final is 0. and then looking for the change in x, distance covered, okay. And but then here, because it's coming to 0 from 2, we need to find that acceleration, okay. Now to get this acceleration, so that we can find the distance, we're going to use F net equals to ma. We can use F net equals to ma. F net equals to ma, okay. So in here, our net force we said is 116, okay. The mass we said is 20, then A, so divided by 20, divided by 20, divided by 20. Don't forget we said it's negative, so negative here. Okay, so divided by 20. So our acceleration is going to be negative what? Calculators. Negative 5,8. Negative 5. Negative 5,80 meters per second squared. Yes, we can now find the distance. We know that if you remember, we can use V final squared, V final squared, okay, equals to V squared plus 2A change in x. Okay, so here squared equals to 2 squared, okay, 2 squared, n plus 2 times negative what? Negative 5,8, 5,8, then our delta x here. Okay, so now if you compute this one here, our delta x given by negative 4 divided by negative what? 2 times 5,8. Okay, and so our distance here, what do you get, calculators? What do you get? What do you get? Here I'm getting 0,34 meters. 0,34 meters. Oh, thank you so much for watching. Catch you in the next video. Don't forget to share and subscribe and comment on the video. Bye bye. Yeah, question 2 made June 2021. It says that June 2 made June 2021 says that an 8 kilogram block on a rough horizontal surface is connected to a 2 kg block by a light inextensible string passing over a frictionless pulley as shown below. The 8 kilogram block moves at a constant speed when pulled by a 29,6 Newton force, horizontal force to the right. The frictional force acting on the 8 kilogram block is 10 newtons. So this 10 newtons frictional force acting on this 8 kilogram block. Okay, this 2.1 state Newton's second law of motion in waves. I repeat, an 80 kilogram block on a rough horizontal surface is connected to a 2 kg block by a light inextensible string passing over a frictionless pulley as shown below. The 8 kilogram block moves at a constant speed when pulled by a 29,6 Newton horizontal force to the right. The frictional force acting on the 8 kg block is 10 newtons. 10 Newton's second law of motion in waves. So what do we say? When a net force acts on the body will accelerate in the direction of the net force with the acceleration directly proportional to the net force and inversely proportional to the mass of the body. Then 2.2, draw a labeled free diagram for the 8 kilogram block. Now if you look at our given diagram here, they said that the 8 kilogram block is going in this direction, okay, meaning that the force is pulling this way, and then the tension force is pulling this way, and then frictional force also pulling. must be opposing what? The motion. But the 8 kg block has got the weight, okay? That's Fg. Then also have the normal force on the what? On the because of the surface, okay? So that's F normal. So our free body diagram is going to be like this. In that case, we have it like this now. Just like this. Here we have the applied force, which is horizontal, okay, being opposed by the tension force and frictional force. Okay, so in this case, this would so then we have the what? We have the applied force, which is the 29, comma what? 29,6. Then we have the tension here. Tension here. Now this is the force. You can put F, or you can put 29,6. It is all fine like that. Okay. 29,6. And then we have the force together with the what? With the weight of the block. Okay. Hope we are together. Don't forget there's also frictional force. Okay. So this is the weight Fg. And then here we have the normal force, which is F normal. F normal. Then you have the frictional force, which is opposing. Okay, frictional force, which is opposing the motion. So, which we call kinetic friction force, it is moving. So that is it there. So this is our F kinetic. Okay, that is it there. Then they say calculate the T equals to MA. Because we know the forces here, we're going to use them here. We don't know the tension here, so we can't use it. Okay. We don't know the acceleration, so we can't use it. Okay, so we're going to use, we're looking for the tension anyway. Yeah, you can use this one here actually. It's going up by the tension here. And then opposed by what? By the Fg. Okay, so that's our 2 kg block. Our 2 kg block, because of the constant acceleration, because of the constant velocity. So we're going to say that the tension minus our Fg minus Fg equals to Ma. Equals to Ma. Okay. But because of the constant velocity or constant speed, going to be equal to 0. Okay, so our T equals to Fg, but the Fg for the 2 kg block is same as what? 2 times 9,8. 2 times 9,8. And this our tension T equals to what? 19,6 newtons. 19,6 newtons. Okay. That's our answer here. The next here, they say that now the 29,6 newton horizontal force is now increased to 50 newtons. They say apply. Oh, yes, we are saying that the 29,6 horizontal force is now increased. To 50 newtons. Then they say apply Newton's second law to each what? To each block and calculate the magnitude of the acceleration of the 8 kg block. Okay, so we want acceleration for the 80. Okay, so now they said we must apply Newton's second law, so we must use F net equals to Ma. Net equals to Ma. Okay, so 2.4.1. If we say F net F net equals to MA T minus FG, okay, minus FG equals to MA. So now we can substitute now. We don't know this tension T, it's a new tension because of the increase in the force now. But the FG is still 2 times 9,8. 2 times 9,8 equals to 2A. Equals to 2. So our tension T equals to 2A plus 19,6 plus 19,6. 19,6, this is 2A. Okay, so that's equation 1. Then now on the 8 kilogram block, on the 8 kilogram mass, okay, now the force is now 50. It is no longer 29,6, but it's 50, né? So we're going to say 50 minus tension altogether minus the frictional force, which is, because we did not change the mass of the block, it is really 8, so it's going to be 10, so minus 10, okay, equals to MA, equals to MA. Now the MA is the times acceleration now, so here gives us 40, okay, it's going to be 40 here, then minus 80, 40 minus 80A equals to our tension here again, so we can say this equation 2, equation 2. Now because the two equations are all equal to tension, we can say equation 1 equals to equation 2. Equation 1 equals to equation 2, and so our 2A plus 19,6 plus 19,6 would be equals to 40 minus 8A. 40 minus 8A. Okay, so from here, if I continue here to simplify, what do we get? Now the 8A become positive 8, make 10A here. This is 10A. Now that side, the 40 minus 19,6, 40 minus 19,6, and then divide by 10. Divide by 10. So our acceleration equals to what? Calculators, what do you get there? Acceleration equals to 2,04. 2,04. 2,04 meters per second squared. Okay, that is it there. And then they say finally, calculate the tension in the string. Now from our first equation, our tension T equals to 2A plus 19,6. 2A plus 19,6. All right, so, but we have the acceleration now. We're going to say 2 multiplied by 2,04, 2,04, 2,04, then plus 19,6. Which answer do we get here? Which answer do we get here now? Calculators. That is 2 into 2,04 plus, it gives me 23,68. So this is 23,68. 23,68 newtons. Right, that was question 2.4.1. Thank you. Question 2, November 2020. A 20 kilogram block resting on a rough horizontal surface is connected to to blocks P and Q by a light inextensible string moving over a frictionless pulley. Blocks P and Q are glued together and they have a combined mass of M. A force of 35 newtons is now applied to the 20 kilogram block at an angle of 40 degrees with the horizontal as shown below. Okay, they say the 20 kilogram block experiences a frictional force of magnitude 5 newtons as it moves to the right at a constant speed. So it is moving to the what? To the right at a constant speed. Did you see that? Alright, what must we do now? They say define the term normal force. Define the term normal force. Normal force is the perpendicular force exerted by the surface on the object in contact with it. Then 2.2, draw a labeled free body diagram of the 20 kilogram block. They're giving us 5 marks here. So we should be having 5 arrows coming from the dot. Now, because we are going in this direction, it means that we're going to have our tension here, our tension T, and then we're going to have frictional force opposing the motion, that's our Fk, and then we're going to have this component, this force here, the 35 newtons force, okay, and then this surface here, and then the weight, okay. So the weight vertically downward, that's our Fg, and then the surface exerts a normal force, that's it. So these 5 forces coming from the dot is going to be our free body diagram. So here we go. We're going to have this one here first of all, okay, this one here, the 2 horizontal, that's frictional force together with the tension, then from there, then now we're going to have the other 2 forces again, that is the normal together with the weight of the blocks, okay, now we together, and then we have another force which is 35 newtons at an angle, this one here, I think you can see that now, it's at an angle, but they all come from one dot, one big dot which we call the free body. So this is the other force which is, okay, yes. So now because of the free body, we must put a dot now here. Our dot here shows the free body, okay. So this dot shows the free what? The free body. Don't forget we must label these forces. This is our F normal, you can call it normal force. This is our weight Fg, okay, and then this is our tension taking the block to the right, okay. This is our 35 newton force at an angle of 40 degrees, okay. And here we have the frictional force. Because it's moving, we call it kinetic frictional force. So those are the 5 arrows for the 5 marks. Now they say here that calculate the combined mass M of the 2 blocks. Okay, so now because they're moving at a constant speed, it means 0 acceleration, and so for that matter, this is now 2.3. So for that matter, our F net equals to 0. So our F net, which equals to MA, will give us a 0. If you look at our first diagram here, the 20 kg block, our tension T is opposed by the frictional force, that is Fk, and also opposed by the component of the 35 which is horizontal. this component here, guys, this horizontal component here, this one for the 35 Newton force, this one here, horizontal component here, and it's given by what? It's given by this angle here, which is 40. As you can see, it is adjacentness. So we're gonna say minus fx, okay, minus fx, and then equals to ma, which equals to 0. So from here, my tension T is equal to the frictional force Fk, but they gave it to us anyway, so I better substitute it now. Frictional is it is 5 newtons. This one here, so this is 5 newtons. Then plus our Fx. Now our Fx is the same as 35 cos of 40 times cos 40 times cos of, okay, here because of velocity, or you can say constant speed. Okay, so in that particular case, it's going to be my Fg minus T equals to ma. Fg minus T equals to ma. So our Fg minus T equals to ma, which equals to 0. So how do you find the Fg? The mass which you're looking for times 9,8. Okay, and then minus T. At T we got 31,81 because the string is inextensible, meaning the tension is uniform throughout. Okay, so from here our mass M will be given by 31,81 divided by what? Divided by 9,8. What do you get, calculators? What do you get? So here my calculator, it gives me 3,25 kilograms. 3,25 kilograms. Okay, that was question 2.3. Now 2.4, they say at a certain stage of motion, block Q breaks up and falls down. This Q here, it falls down, okay? And then how would each of the following be affected when this happens? The tension of the string is decrease or remain the same. Now, because we are decreasing on the pulling force, this is the pulling force here, which is governed by the mass, but now the mass decreases because Q is breaking off. So if the Fg decreases, then now the tension is going to decrease. So the tension decreases. That's our answer here. Then they say we also have the 20 kilogram block. Now this 20 kilogram block was being pulled by the tension here, but because the tension is decreased, then the velocity will also decrease. So velocity will decrease. Velocity will do what? Will decrease. They say explain your answer. Explanation here, because of the decrease in the tension, now the acceleration is going to be to the left, okay? Because now the acceleration is in the opposite direction. Or you can say because now the acceleration is to the what? Is to the left. Acceleration is to the left. Acceleration is to the what? Is to the opposite direction. Or you can say is to the left. Is to the left. Okay. Alright, guys. That was question 2, November 2020. Thank you. All right. So this is November 2019, question 2. Block P of mass 2 kilograms is connected to block Q of mass 3 kilograms by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees to the incline. Block P moves on a rough section AB of the incline, while block Q moves on a frictionless section BC of the incline. See diagram below. One more time. Block P of mass 2 kilograms is connected to block Q of mass 3 kilograms by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees to the incline. Block P moves on a rough section AB of the incline, while block Q moves on a frictionless section BC of the incline. See the diagram below. They say here that they say that an average frictional force of 2.5 newtons acts on block P as it moves from A to B up the incline. State Newton's second law in words. How do we state it? A net force acts on the body. The body will accelerate the direction of the force, with the acceleration directly proportional to the force and inversely proportional to the mass of the body. Let us say it together. When a net force acts on the body will accelerate in the direction of the force, with acceleration directly proportional to the force and inversely proportional to the mass of the body. Okay, now 2.2 here, they say draw a labeled free body diagram. Now this block P here, as you can see, I've got tension pulling it upwards. Okay, this tension is opposed by frictional force. The surface is rough, opposed by frictional force here, that is Fk, because it is in motion. Okay, and then it has got weight. Okay, it has got weight here, which is Fg, and then it's on the surface, so we exert a normal force. Okay, so this is F normal, and those are the 4 F max here. So here we go with our free body. So the first pair here is going to be for the tension and the frictional force. The tension and the frictional force. The tension is what you can see it there. Okay, and then the frictional force is acting down the slope. Okay, so and from that now we have the normal force, which is normal to the surface, which is perpendicular to the surface like this. As you can see my drawing, it is almost 90 degrees. It is almost 90 perpendicular, right? So that's how it looks there. And then now we have the weight. Which is vertically downwards. Now the weight must be vertically downwards like this. By the way, if you don't want to draw the weight, you can use the components, whereby we have the component, and then is what? Section AB. Okay, so now because the two blocks are connected by this string, you're gonna use Newton's laws of motion, Newton's second law of motion applied to each block, and then because they are being connected by something which is inelastic, then we'll have the same acceleration. So here we go with the 2.3. Our net force, or F net, okay, our F net equals to MA. Now in this question, they did not tell us that we are moving at a constant what? At a constant speed. So we don't equate to 0. So if you look at the 2 kilogram block, okay, the 2 kilogram block, I can see that the tension, okay, minus frictional force, that's Fk, minus frictional force, then minus the component of gravity which is parallel to the slope, that's Fg parallel, okay, Fg parallel equals to Ma, equals to Ma, okay. If I do substitute here, the tension, I don't know it yet. I'm gonna say T, I know, okay. The Fk I know. The M is the 2, it's gonna be 2A. Now the Fk become what? Become positive, okay. We can say plus what? Plus Fk, which they said is the 2 newtons here, 5 newtons, okay. So this is 2,5 here. And then also the Fg become positive, given by mg sine 30. The mass is 2. The g is 9,8. 9,8. Then sine 30. Okay. So we're going to get our first equation here by saying our t is equal to 2a. Now if we simplify the 2,5 plus the 2 times 9,8 sine 30, what do you get? Times, what do you get there? Here it gives me 2a plus 12,3. So this is 12,3. 12,3. I'm gonna say this is equation 1. Hope this is equation 1. Then if I look at the other block now, which is the 3 kilogram block. Now the 3 kilogram block, as you can see, this force, the force is at an angle of 25, né? But because we are moving parallel to the slope, I'm gonna take what I'm gonna call Fx. Okay, this is now Fx. Now the Fx is the which is pulling the system here. So now I'm gonna use cos because it is adjacent. So I'm gonna say 40. Okay, let me first say Fx. Okay, not the equation first. My x, right, guys, minus the tension. Okay. Now here there's no friction, né? But we have the component of gravity, which is what? Which is parallel to the slope, né? So minus Fg parallel, okay, equals to Ma, equals to Ma. Let us now substitute here. Now here, the force is T, and the angle is 25, né? So I'm gonna say that 40 cos 25, né? 40 cos 25, 40 cos 25, 40 times cos of 25, né? Cos 25, then minus T, I don't know yet, minus Fg parallel, given by mg sine 30, given by mg, but the m is the 3, okay, times 9,8, times 9,8, then sine 30. The angle of inclination is 30 times sine 30 equals to 3a, equals to 3a. If I simplify my things, I am gonna see that here now I have 20. If I have this 40 cos 25 minus 3 times 9,8 sine 30, it gives me 21,55. So this is 21,5 and another 5 here, okay? Then now the 3a become minus, so minus 3a equals to T, the tension, and so this is equation 2. This is equation 2. The two equations are equal to tension, so I can say equation 1 equals to equation 2. Equation 1 equals to equation 2. And so for that matter, I'm going to say that now, don't forget that my equation 1 I'm talking about is this one here. So meaning this 2a plus 12,3 should be equal to the 21,55 minus 3a, because they're both equal to tension, okay? 2a or the 21,55, okay, minus what? Minus 3a is equal to 2a, equals to 2a plus 12,3 plus 12,3. Okay, so if I simplify here, the 21,55 minus 12, it gives me 9,25. So this is 9,25, and then the 2a plus 3a give us 5. So then divide by 5, our acceleration is 1, here? 1,85. 1,85 meters per second squared. Meters per second squared. That's the acceleration which they wanted here. Next question here. They said now that if block P has now passed point B, okay, how will its acceleration compare? How will its acceleration compare to that calculated in equation 2,3? Choose from greater than, smaller than, or equals to. Give a reason for your answer. Now, when we pass block P, there's no more friction, and so because of that, the pulling force, which is F of x, is only opposed by the FG parallel frictional force. That the net force now is going to increase up the slope, and because the net force increases from Newton's second law of motion, then the acceleration increases. Why? Because acceleration is directly proportional to the net force. So we say here it's going to be greater. It's going to be greater than. Why? Because now when we pass point B, the net force increases. The net force increases. So because the net force increases up the slope, okay, increases, then, and we know acceleration is what? Directly proportional to the net force, okay. So then acceleration will increase, therefore then will increase. Acceleration increases. All right, guys, I hope we are together. That is our answer for this question. Thank you so much for watching. See you in our next question. Bye bye. All right. This is question 2. November 2019. Okay. 2019, question 2. It says that a person pushes a lawnmower of mass 15 kilograms at a constant speed in a straight line over a flat grass surface with a force of 90 newtons. The force is directed along the handle of the lawnmower. The handle has been set at an angle of 40 degrees. Refer to the diagram below. Then they say draw a labeled free-body diagram of the lawnmower. Draw a labeled free-body diagram for the lawnmower. So now, as we draw this, understand that the lawnmower is this one here. Okay, it has got the what? Has got the weight, okay, or Fg, and then what you can call the surface exerts what? Have the frictional force. You have the frictional force, this one here, which is opposing the motion of the. But because the lawnmower is going to the right, then friction must be facing where? To the left, né? Okay, because friction is the force which opposes the motion. Then the applied force is acting at an angle from the lawnmower. That was like this. If you check what we had before, our force, if I come to this main here, you see the force is along this handle. Then it goes away like this. Okay, so for that case, our force for the lawnmower, which is applied, will come like this. It's at an angle, so this should give us what? The free body diagram. Hope we are together. That is how we draw it. That's how we draw it. So we say here, this is our free body, okay? This is our normal force, because the surface exerts a normal force on the lawnmower, and then it has got weight Fg, okay? And then we have the frictional force. Applied force, they give us, they say it is 90 here, so we better put 90 newtons here. Now in this case, we don't have to show the angle of inclination. All right, that's our answer for the free body diagram, okay? And then they say next here that why is it correct to say that the moving lawnmower is in equilibrium? Why is it correct to say that the moving lawnmower is in equilibrium? It is because the acceleration equals to 0. It's because now the constant speed means 0 acceleration, okay? And if acceleration is 0, then it's going to be in equilibrium. So it's because acceleration is 0. The moment is 0, it means it is what? It is at equilibrium. And then here they say calculate the magnitude of the frictional force acting on the lawnmower, acting between the lawnmower and the grass. So we're looking for this frictional force, which is Fk, okay? Now, because of the constant speed here, we can say that the 2.1.3, our F net equals to MA, which equals to 0. F net, okay, equals to MA, which equals to 0. Why? Because of the constant speed. But in this case, guys, as you can see, because it's going to more, it is taken up by this component, which you call horizontal component here. I'm going to call it Fx, okay? What is horizontal? So I'm going to say the horizontal component Fx minus frictional force I'm looking for equals to 0. Okay, so then from here now, you see, remember the angle was 40 here. If this is, it means that if I can extrapolate this one here like this, if I can extrapolate it and then make it longer like this, application, and I come like this now. I want to be careful here. I want you to watch this. See here, I was having the 40. This is the 40 here. So if this is 40, now this line is parallel to this one here. They are parallel. So these are corresponding angles. So this one is also 40. It's also 40. And now the fx being adjacent, I have to use cos. So I'm gonna say cos 40. So it's 90 cos of 40. 90 of 40 degrees, okay, equals to fk, which we are looking for. So from the calculator, what do you get on the calculator there? What's our fk equals to? Here, it gives me on my calculator, it gives me 68,94. 68,94. 68,94 newtons. And I hope, guys, we are together. That's our pictures. Then they say here that now, you know what? The lawnmower is now brought to a stop. Calculate the magnitude of the constant force that must be applied through the lawnmower from rest to 2 meters per second in a time of 30 seconds. Assume that the frictional force between the lawnmower and the grass remains the same as in question 2.1.3. Meaning I'm going to use the same frictional force here, which is 68,94. Now, I'm looking. So this time, because it is accelerating, it's not moving at a constant speed, okay. So from F net is 2.1.4. 2.1.4. From F net equals to MA. F net equals to MA. If I can get my acceleration first, that have to be much better. Now acceleration is given by what? By final velocity, initial velocity, divided by change in time. So final velocity minus initial divided by change in time, right, guys? So because it's from rest to 2, it's going to be 2 minus 0 divided by 3. Divided by 3. So it is 2/3 as my acceleration. But then F net equals to MA. I know we saw that our Fx minus frictional force equals to MA, okay? Equals to MA. Okay? Let us now substitute. Now the mass of the lawnmower has got how many kilograms? They said here it is, let's check it here. They said 15 kilograms, so 15 kilograms here. So when I come back here, I'm going to say that now this Fx, like we saw, is given by the force F, which was 90 in that case. The force F times cos of 40. So the force times cos of 40 degrees minus frictional force, which is what? Which is 68, right, guys? 68,94. should equal to what? Should equal to okay. All right, guys. Make it a little bit bigger here. Sorry about that. Okay. Yeah, 68.94 should be equal to MA. Equals to MA. Now the mass is 15, like you saw it up there. Acceleration we got 2/3, right? So 2/3 here. And then from here now, my F cos of 40 will be to the 10. Here I get 10, the 10 plus 68.94. 10 plus 68.94. So from here, my force equals to 78.94 divided by what? Divided by cos of 40. Hope we are together. Divided by cos of 40. Okay, so here, calculators, here we get calculators. What do you get? You're getting 103.05. 103.05. 103.05. 03.05 newtons. So that was the original force, okay? That was the original force. Then lastly here, they say planet Y has a radius of 6 times 10 to the power 5 meters. A 10 kilogram mass weighs 20 tons on the surface of the planet Y. Calculate the mass of planet Y. I repeat, planet Y has a radius of 6 exponent 5 meters. A 10 kilogram mass weighs 20 newtons on the surface of planet Y. Calculate the mass of planet Y. Okay, now we know that first of all, how do you find weight? How do you calculate our weight? Weight equals to mass, okay, times what? Times gravity on that planet, or just call it G prime. So the weight they are given to us is 20. 20 equal to the mass. They say the 10 kilograms, so 10 times G prime, okay? So in this case, my gravity on that planet G prime equals to 20 divided by 10, which gives us 2. Which gives us 2 meters per second squared, okay? But then the formula, the gravitational acceleration on any planet is given by G, the universal constant G, then mass of the planet, in this case planet Y, okay, planet Y divided by the radius of that planet Y squared. So in here, looking for the mass, right? So the mass of planet Y equals to the gravitational acceleration G prime of planet Y squared divided by the universal constant G. So when we substitute now, our G prime we got 2, okay? Radius was given to us here as 6 exponent 5, so open bracket here, 6 times 10 to the power of squared, alright, squared. Then divided by universal constant G, which is 6, what? 6,67 times 10 power negative 11, right guys? Now this one you get from the formula sheet, ne? Don't need to cram this. What do you get from your calculator? Who can tell us here? Calculator gives you what now? Talk to me. Here it gives me 1 exponent 22 1 comma 08 times 10 power 22 kilograms. 22 kilograms for this planet. Okay. All right, guys. I hope we are together. Thank you so much for watching. See you in our next question. Don't forget to share, subscribe, and comment on the video. Oh yes, question 2, November 2018, question 2. A block of mass 8 kg is placed on a rough horizontal surface. The 8 kg block, which is connected to a 2 kg block by means of a light inextensible string, passing over a light frictionless pulley, starts sliding from point A as shown below, from point A, B, and C. Okay. They say 2.1, state Newton's second law in words. When a net force acts on the body will accelerate in the direction of the net force, with the acceleration directly proportional to the force and inversely proportional to the mass of the body. Then 2.2, draw a labeled free body diagram for the 8 kilogram block. Now 8 kilogram block is on the surface. Okay, so there is weight and then normal force. Because the table is a rough table, we have frictional force, then we have got this force at an angle. So the tension is at an angle here. So for that matter, 2.2, we're gonna need something like this. 0.2. We have this one here, the normal force and the weight, because it is a mass and the height on the table and has got weight. Okay, so the table exerts normal force and then the weight because of the mass. Then we have the frictional force, which is opposing the motion. Now frictional force, because the block is going to the right, friction must be to the right, must be to the left, okay. And then now the tension is at an angle, here, at an angle, and so put like this. At an side we must label this free body diagram. So here we must label it by using a dot. Okay. So we use a dot here to label this free body diagram. And so here we put our dot to show the free body. Don't forget we must label the arrows here. This normal force here. This is the weight, which you can call Fg. Okay. This is the tension. You see it's at an angle of 15 degrees. This block is moving, so it has what? Kinetic frictional force. Okay. The next question here, 2.3. When 8 kg block reaches point B, the angle between the string and the horizontal is 15 degrees. And the acceleration of the system is what? 1,32. So they say 2.3.1. Give a reason why the system is not in equilibrium? It is because the acceleration is not equal to 0. It is because acceleration is not equal to 0. As long as it's not equal to 0, it is not in equilibrium. Okay? It's not in equilibrium. That's our reason here. Then they say use the 2 kg mass to get the tension in the string. We're looking for the tension in the string for using this 2 kg. Now, because it's going this direction here, the 2 kg is going downwards, okay? And so, because of that, oh yes, they say use the 2 kg mass to calculate the tension in the string. Now that we know the acceleration and the 2 kg is going downwards, ne? Why is it going down? Because it is pulled by what? Pulled by Fg, okay? And then it is opposed by the tension. So I want to second mostly Fg minus T, okay? So 2.3.2, I'm going to use Newton's second law of motion, where I say F net equals to ma. F net equals to ma. Since I know the acceleration, then I can find my tension, right, guys? Okay, so like I showed you here, the force of gravity, okay, minus what? Minus the tension I'm looking for equals to ma. Let us now substitute, okay? So in here, our Fg is mass times gravity, that means 2 times 9,8. 2 times 9,8. Then minus tension we're looking for, which is 2, times acceleration, which is 1,32. 1,32. So if I do my calculations here, my tension T is equal to 19,6 minus what? Minus 2, which gives me what here? Which gives me 16,96, which is 16,96. Now, because this is the same tension which you see here as 16,96 would be the same, 16,96, 16,96 would be the same tension even here, because the tension, the string is inextensible. So even here, T equals to 16,96. Does it make sense to you? As long as they say the string is inextensible, that's what we mean. We mean tension is distributed equally throughout, okay? That is my answer there. Then 2.3.3, what do they want now? They say here that they calculate the kinetic frictional force between the 8 kg block and the horizontal surface. So I want now the kinetic frictional force between the 80 kilogram block and the, yes, so now this tension is at an angle, and so if you check properly, the component responsible is the horizontal component for the tension, which you call Fx, right, guys? Then it is opposed by frictional force, which is the Fk, which I'm looking for. That is kinetic frictional force. So because I'm going like this, my Newton's second law, F net equals to ma, will give me Fx minus Fk equals to ma. So 2.3.3. Again, I use what? Newton's second law, that is F net. F net equals to ma. F net equals to ma. Okay, so when I substitute here, we are going to say that Fx Fx, that is the horizontal component of the tension, minus frictional force, kinetic, that's Fka, equals to 8 times A, equals to 8. Notice the same acceleration, eh? That is 1,32, 1,32. And then, from here now, our Fx is going to be 16,96 cos 15, right? Copy it together, guys. 16,96, 16,96, then minus frictional force that I'm looking for, that is Fk, equals to 8 times 1,32. What do you get? What's be 1,32? Okay, final answer here for my frictional force. This is 8 times 1,32. My frictional force Fk, it becomes, my calculator here, it becomes 5,82 newtons. 5,82 newtons. Then they say now that that is question now 2.4 here. As the 8 kg block moves from B to C, the kinetic frictional force between the 8 kg block and the horizontal surface is not constant. Give a reason for this statement. Now, guys, as you see here, the more you get closer here, there's an increase in the angle. Like you see, it is 15 for now, but more than maybe 20. So as it does so, it is pulling the box upwards, okay? Meaning the normal force keeps on changing. So because of the changing in normal force, then it means that the frictional force will not be constant. Okay, so we say here, it's because of what? Because of the changing in normal force. Because of the changing normal force. Because of changing the normal force. You know, frictional force depends on normal force, ne? So if normal force changes, then what? Then you expect frictional force to change, because frictional force is proportional to normal force. The surface on which the 8 kg block that is February, March 2018, question 2. It says, resting on a rough horizontal surface are connected by a light inextensible string. The boxes have masses 5 kg and 2 kg respectively. A constant force F acting at an angle of 30 degrees to the horizontal is applied to the 5 kg box as shown below. The two boxes now move to the right at a constant speed. This is a rough surface here. State in space of motion in words. What did we say? A body will continue in its state of rest or continue moving with a constant velocity unless what? An external forces or unbalanced force acts on it. Then they say draw a labeled flow diagram for box Q. Now box Q is this one here. It's on the surface. So we have the weight and normal force opposite each other, then the tension, and then opposed by frictional force. But because it is moving to the right, then the tension must be to the right. So our 2.2 here, we're going to have our arrows here like it is, okay? We have to the right is tension, okay? What about to the left? It is the applied force, the frictional force. Then up is normal force. What about down? Down is the weight. So up, normal force, and then down is the weight. Okay. All right. So here, this is what we have here. So up here, F normal. Okay, F normal, and then down here is the weight. You can say Fg. This side is the frictional force. Because it's moving, we say kinetic. This is our tension in the string T. Next question. Box P experiences a constant frictional force of 5 newtons and box Q 3 newtons. Okay. Calculate the magnitude of force F. We're looking for this force F now. They're giving us 6 marks here. So to get our force F here, we need to first know this tension here. When we know the tension here, then we can be able to get our force F because we're going to be having two unknowns. But to know this tension here for P, I need to first know the tension for Q because it's the same string, okay? So because the Q is going to the right as well, I'm going to say T minus frictional force MA. And because of the constant speed, I'm going to equate it to 0. So here we go. For 2.3. Our 2.3, begin by saying F net equals to MA. F net equals to MA. F net equals to MA. And because of the constant speed, we're going to equate it to 0 since it's not accelerating. Okay, so now look at our 2 kg block. Our 2 kg block, we're going to say that our tension T, right, minus frictional force equals to 0. And so, because they gave us the frictional force for block Q, which they said is 3, is actually equal to 3 newtons. Equals to 3 newtons, okay? But because the string is inextensible, okay, the string is what? Inextensible. It means they're going to be the same tension here. So, and then this force is at an angle, né? So, what is taking the block is actually called the horizontal component, which you call Fx. And being adjacent, I use cos. So I'm going to say that again, now I talk about now the 5 kg block, okay? So the 5 kg block to be considered, my F net equals to MA, it gives me X, Fx, okay, minus what? Fx minus T altogether, and then minus frictional force, okay, equals to 0 because of the constant speed. Ne? So in here then, my Fx, the horizontal component, okay, is going to be given by Fx equals to the tension altogether, tension T, then plus what? Plus Fk. So here, our tension, already we got 3. What about our Fk for the 5 kg block? They gave us what? They gave us, okay, that's block P, so it's plus 5 here. Okay, so, but what is our Fx? The same as saying 80, because the Fx is adjacent, né? So in mathematics, we use cos of what? So in other words, my force that I'm looking for, I'm going to say my force F equals to 8, okay, divided by cos of 30, okay, so calculate as what do you get here? 8 divided by cos 30, it gives us what? Here it gives me 9,24. I get 9,24. 9,24 newtons. That's how here. Well, now they say that the connecting string P and Q suddenly breaks. The string connecting P and Q suddenly breaks after 3 seconds, while the force F is still being applied. Learners draw the velocity time graph for the motion of P and Q before and after the string breaks, as shown below. Okay, so what do we do now? They say, write down the time at which the string breaks. So you see here where here at first they were moving together at the same velocity. Now at this point here, that's where the string breaks. So must be time equals to 30 seconds. So the time t should be 30 seconds. So at t equals to 30 seconds, that's when the string breaks. Then they say which portion x, y, or z of the graph represent the motion of box Q after the string breaks. Use the information in the graph to fully support your answer. Okay, don't forget that we're talking about Q, box Q. Now the box Q is on at the back here. So when the string that are now the remaining force acting on it is the frictional force, and the frictional force is going to cause it to accelerate in the negative direction. Okay, so our acceleration is going to be opposite. Our net force is going to be opposite, and because of the negative acceleration, then the velocity must be decreasing, like you see it here. So the answer is y. So I'm going to say here it's going to be y. Let's say we must choose the portion. Going to be y here. We choose y. I'm going to say y. It is y. Okay. They say for the x now. The acceleration is in the opposite direction. Okay. Because acceleration is in the opposite what direction? Acceleration is now in the opposite direction. Okay, and acceleration is now opposite direction, and so because of this, velocity decreases. So velocity decreases. Velocity decreases. Velocity decreases. Velocity decreases as y decreases as is seen on the graph of y. You see with the x it is increasing, which means this x must not be for q, but rather that x should be for the other one now. This one here, this p, because after this string was broken or snapped, then this one continued to move at a higher speed, higher velocity. Okay, so let us proceed then here. 2018 this have been the supplementary. Okay, they say here block P of unknown mass is placed on a rough horizontal surface. It is connected to a second block of mass 3 kg by a light inextensible string passing over a light frictionless spool as shown below. So this is our P passing over here as shown below. So meaning our P, okay, then this one is going down like this. Okay, They said that initially the system of the masses is held stationary with a 3 kg block 0.5 meters above the ground, like you see it here. When the system is released, the 3 kg block moves vertically downwards and responds. Ignore air resistance. Okay, define the term acceleration words. What's acceleration? Is the rate of change in the velocity of an object. Then calculate the magnitude of the acceleration of the 3 kg block using equation of motion. So we're looking for acceleration now. Now what do we know? Acceleration, we know it was held stationary, meaning v initial is 0. This is our change in y here, okay, and they gave us the time. So v initial was 0, okay, and so because of this now, what do we do? Using equations of motion, okay, so we can use change in y, okay, change in y equals to v initial times change in time plus a half a, right guys? I'm looking for the acceleration. So the change in y is 0.5 meters, so 0.5 meters, okay. Now because it was held stationary, v initial was 0, so this is 0 times the time taken, which is 3 seconds to hit the ground, then plus 1 over 2 times this acceleration which I'm looking for, again times 3 squared here. So now this is 0, this is 0.5. So to get my acceleration, I'm going to say 0.5 multiplied by 2, then divided by 3 squared, which is 9, okay. So to get my acceleration, so from my calculator here, I am getting what here? My calculator here, it gives me 1 over 9, or you can say 0.11. 1 over 9, or you can say 0.11. 0.11. So the acceleration here, because they said magnitude, okay, acceleration equals to 0.11 meters per second squared, okay. All right, next question then, the tension in the string. Now that I know the acceleration and it's going downwards, I know it's taken by Fg, okay, taken by Fg, and then opposed by the tension. So I'm going to say Fg minus T equals to Ma. So 2,3, I say, if I use F net equals to Ma, since it is in motion, F net equals to Ma, F net equals to Ma, then I can go ahead and say the force of gravity, that's Fg, okay, Fg minus the tension should give me what? Should give me Ma. So because I have the acceleration, I have the mass as well, I can find my tension. How do you find Fg? Mass times gravity. I'm going to say 3 times 9,8. 3 times 9,8 times 9,8 minus the tension I'm looking for. So minus T is equal, the mass we know it is 3, double the acceleration, 1 over 9 or 0.11. So I'm going to say 1 over 9 to make my things more accurate, okay. So here, if I do my calculations, my T equals to what here? My T here becomes 29,07. 29,07 0.07 newtons. That's my tension here. And then they said that now the magnitude of the kinetic frictional force experienced by the block P is 27. So what must I do for you guys? Draw a labeled Fibo diagram for block P. Now block P is on the surface here, we know it has got weight opposed by frictional force, that's Fk, and then normal force, and then the tension. So that meaning that my thing here, my freeboard diagram is going to be like this. Hope you agree with me, guys. We have the frictional force opposing the motion, and we have the tension. We have the tension forward. Then we have the normal force and the weight. Okay, normal force and the weight. Okay, so I'm gonna put a little bit here. All right. So now, because I want a free body, I'm gonna put what here? I'm gonna put the free body by putting a dot. That dot means it must be a big dot, né? So this is a dot here. The free body, okay. This is my normal force, F normal, okay. This is our frictional force. The surface is rough, né? This is the weight Fg. And then this is the tension. Now let's calculate the mass of block P. Now that I know the tension, let's check properly. Now, because the string is inextensible, guys, the tension which you got must be the same tension in here. So this tension of 29,07 here, this one, be the same tension here now. 0.07 newtons. Now looking for the mass of P. So because it's moving, and I know the we know the friction, I'm looking for the I just got friction, right? Let me check it again here. Okay, the friction is given to me 27, right? So if I use my F net equals to MA, okay. If I use what? F net equals to MA, I think I'll be sorted. So F net equals to MA. F net equals to MA equals to MA. Okay, so now the tension of by frictional force Fk should give us MA. Should give us what? MA. Right, guys? Should give us MA. But we know the acceleration and we know the mass. We're looking for the mass actually. So the tension here which we got as 20 what? 29,07. Yes, we're gonna say here 29,07 minus frictional force here given to us as 27. So minus 27 here equals to the mass we're looking for times the acceleration, which is 1/9, right, guys? 1/9 here. So the 29,07 minus 27 is going to be 2,07. So this is 2,07 now multiplied by 9 should get the mass here, the mass of P. Okay, now calculators, what do you get there, guys? Calculators, here I'm getting 18,63 kilograms. All right, guys, that was all for this Newton's laws of motion. Thank you so much for being patient with me for all these 4 hours. But like I said, please, to benefit from these videos, you do the question and then you mark your work as you watch the video. Thank you. Don't forget to share, subscribe, and like the video. Bye-bye. Kamala Patrick, tutor, educator, mathematics, physical sciences, online, all at the college, Post College Pulukwane. Shalom.